everyone.
Hello,
Hello.
Caesar, how are you?
Hi.
The giant planet Jupiter, in all its banded glory, takes the spotlight in these new images from NASA's Hubble Space Telescope that capture both sides of the planet. Big enough to swallow Earth, the classic Great Red Spot storm stands out prominently in Jupiter's atmosphere. To its lower right, at a more southerly latitude, is a feature sometimes dubbed Red Spot Junior. This giant storm, called an anticyclone, was the result of other storms merging in 1998 and 2000, and it first appeared red in 2006. The source of its red color is unknown, but may involve a range of chemical compounds, sulfur, phosphorus, or organic material. Staying in their lanes but moving in opposite directions, Red Spot Junior passes the Great Red Spot about every 2 years. Hubble also captured Jupiter's volcanic moon, Io. Only slightly larger than Earth's moon, Io is the most volcanically active body in the solar system. Hubble's sensitivity to blue and violet wavelengths clearly reveals interesting surface features. Hubble monitors Jupiter and the other outer solar system planets every year under the Outer Planet Atmosphere's Legacy Program, or OPAL. These large worlds are shrouded in clouds and hazes stirred up by violent winds, causing a kaleidoscope of ever-changing weather patterns for Hubble to investigate. Studying the planets in our solar system helps us understand our own weather patterns closer to home, and allows us to theorize what potential exoplanet weather is like in other star systems in our universe. The giant planet Jupiter, in all its banded glory, takes the spotlight in these new images from NASA's Hubble Space Telescope that capture both sides of the planet. Big enough to swallow Earth, the classic Great Red Spot storm stands out prominently in Jupiter's atmosphere. To its lower right, at a more southerly latitude, is a feature sometimes dubbed Red Spot Junior. This giant storm, called an anticyclone, was the result of other storms merging in 1998 and 2000, and it first appeared red in 2006. The source of its red color is unknown, but may involve a range of chemical compounds, sulfur, phosphorus, or organic material. Staying in their lanes but moving in opposite directions, Red Spot Junior passes the Great Red Spot about every 2 years. Hubble also captured Jupiter's volcanic moon, Io. Only slightly larger than Earth's moon, Io is the most volcanically active body in the solar system. Hubble's sensitivity to blue and violet wavelengths clearly reveals interesting surface features. Hubble monitors Jupiter and the other outer solar system planets every year under the Outer Planet Atmosphere's Legacy Program, or OPAL. These large worlds are shrouded in clouds and hazes stirred up by violent winds, causing a kaleidoscope of ever-changing weather patterns for Hubble to investigate. Studying the planets in our solar system helps us understand our own weather patterns closer to home, and allows us to theorize what potential exoplanet weather is like in other star systems in our universe.
Telescopes generally come into two different flavors. You have really powerful big telescopes, but those telescopes see a tiny part of the sky. Or telescopes are smaller, and so they lack that power, but they can see big parts of the sky. WFIRST is the best of both worlds.
WFIRST is the Wide Field Infrared Survey Telescope. What I think of WFIRST as doing is building on what were the two great successes astronomically of the 1990s and the last decade. That is the Sloan Digital Sky Survey and the Hubble Space Telescope.
WFIRST is a NASA observatory that has the top ranking of the National Academy of Sciences to launch in the 2020s. It has the same image precision and power as the Hubble Space Telescope, but with 100 times the area of sky that it views.
Looking at a large fraction of the sky allows you to get a more complete accounting. For example, the stars in the Large Magellanic Cloud, which is the nearest galaxy to us, or the stars in the galactic bulge. So you can do a much more complete accounting in a much shorter amount of time. The particular thing I'm interested in using WFIRST for is to actually do a statistical census of planetary systems in our galaxy. And what we're looking for is gravitational microlensing events. These are cases when another star passes in front of our line of sight to a background star, and it makes that background star get a little bit brighter due to the gravity of that foreground star. And that allows us to find planets.
What WFIRST will do is it will have what we call a coronagraph. A coronagraph lets us image and characterize really dim planets next to very bright stars.
No matter how good a telescope that you build, it's always going to have some residual errors. It's going to be the first time that we're going to fly an instrument that contains these high format deformable mirrors that are going to let us correct for errors in the telescope. That's never been done in space before.
WFIRST will allow us to potentially make groundbreaking discoveries, finding out what dark energy is. So this will tell us if dark energy is an unknown form of energy or if it's a modification of general relativity.
Single WFIRST images will contain over 1 million galaxies, and we can't categorize and catalog those galaxies ourselves. Citizen science allows interested people in the general public to solve scientific problems. And so one of the things that I'm really excited about is enabling this bridge where the general public can get involved in doing actual science.
For me, it's a really exciting opportunity to play a significant role in a mission that I think will be one of the most powerful telescopes that we have in the 2020s, and will be some of the most important things our country does in space in that time frame.
Well, hello everyone. This is Scott Roberts from Explore Scientific and the Explore Alliance, and I'm here with my co-host David Levy from Vail, Arizona. We're here in Arkansas where it's just starting to clear after a kind of a cloudy, blustery day. We have a very nice lineup for you tonight with some of our regulars, but also some new faces to Global Star Party. So, and we're less than 2 weeks away. I think yesterday was exactly 2 weeks to the April 8th total eclipse of the sun. So I hope that you got your eclipse glasses. I hope that you got your camera systems ready. If you haven't been out there, if you're going to take pictures and you haven't been out there practicing, you need to do so, so that by the time you get to the eclipse, you've got some muscle memory going on, because if you haven't seen a total eclipse before, it is too awe-inspiring. It messes with your thoughts and your plan on what to do next, and even if you are a veteran of total solar eclipses, you know, practice does make perfect. Are you out there practicing too? David, are you going to try to take any photographs?
No, I might take a picture. or two.
Okay.
But I think everybody's going to be taking pictures, so I will just enjoy it and watch it. Almost certainly cry, both from happiness to see the eclipse and sadness that I know how badly Wendy really wanted to see this eclipse.
Oh,
Uh,
yes.
but I'm really looking forward to seeing it, and I'm looking forward to seeing it with Explore Scientific.
Yep. We've got, if you guys didn't already know it, we have a expedition going down to southern Texas, just north, I think just north of a little town. It looks like it's spelled Leakey, Leakey, Texas, but it's pronounced by the locals there as Lakey. So they probably didn't want to live in a town called Leakey. I don't know. There's always these little kind of weird niggles when it comes to town names and that kind of thing. So, but I'm excited. We're a little tired. We've been getting ready for the eclipse by selling eclipse glasses, and it's been a little exhausting. We had incredible numbers of orders coming in at the last minute here for people that wanted to get ready for the eclipse. We still have inventory if you're looking for it, but the closer that you get, the more unsure it is that you'll actually receive your glasses, because shipping can be a problem, because everybody's trying to ship stuff just before a total eclipse of the sun. But anyways, I wanted to introduce our next speaker here. Now, normally we would have the Astronomical League here. This star party is a little bit different. They were unable to make it. All of the league executive officers are out doing something right now. Probably like Terry Mann, for example. She's been going from town to town to town, getting these towns in Ohio ready for what to expect. From a traffic perspective, from a emergency preparedness perspective, these kinds of things, and then also explaining what this incredible phenomenon is like with the total eclipse. But David, I can't. Gosh, if I think about the most beautiful things that you could ever see in the sky, the total eclipse of the sun has got to be in the number 1 or number 2 spot. What do you think?
Yeah, I think it's in the number 1 spot. I got a
Yeah.
letter from a childhood friend the other day who said that he is on the path of totality in Prince Edward Island in Canada. And he says, I'm going to be very careful. I'm going to close my blinds and stay inside. And I wrote him back and I said, Sammy, don't. You would be missing one of the most beautiful, probably the most beautiful thing that all of nature can provide. And that's saying something.
Yes.
I mean, it's absolutely stunning.
Yes.
And you don't want to be at a 90, 95, 99% eclipse, because it's worth it to travel, brave the traffic, and travel into the path of totality,
Yes.
because you want to see the entire sun go away. And when that moment happens, you take your protective glasses off and you just look up and you see the atmosphere of the sun, and it is absolutely unbelievable. And for those of you who are clouded out, not to worry, because you will still see the great shadow of the moon approaching from the southwest and coming at you and suddenly engulfing you. And the darkest eclipse I've ever seen was the one that was clouded out for me in 1970. I was standing there and I could not see my fingers in front of me. It was that dark. So that's a benefit for clouds, but I hope you'll all get clear sky and a wonderful thing. And am I on now for my little quotation?
Yes, sir. Yep, I'm going to give you the stage.
I can also represent the Astronomical League today.
Could you? Okay, thanks.
Yeah, because they're going to have the Astronomical League Alcon. It'll be in Kansas City this summer, and it's going to be the best. And there's going to be a guy who's going to give a lecture, and he is actually he's a cast member of Star Trek Voyager, and I know that got a lot of you going, and that's Tim Russ. Tim Russ, would you like to hear Tim Russ give a speech about astronomy? Of all the people in Star Trek, especially Star Trek Voyager, how would you imagine when one guy, Tim Russ, comes with a telescope one day and wants to show the cast the night sky? And the rest of the cast had no idea about it, but they were really pretty impressed, as was I, to hear about that. And so it's going to be a wonderful event, and I'd like to invite you all to see it. Now it comes time for the quote. And since I have a little extra time today, I'd like to begin by saying that I'm going to quote Thomas Hardy at a lunar eclipse. And you've all heard that because I've done this before. But this is really special because this comes a couple of days after a lunar eclipse. Not the big solar eclipse of the sun we're going to have in less than 2 weeks, but the one we had Sunday night. There was visible over all of North America what we call a penumbral eclipse of the moon. The outer shadow of the Earth enveloped the moon, and I really wanted to see that. And it was cloudy. Boy, was it ever cloudy, and it was raining. And I went outside around 10 o'clock, and it was not raining hard, but drizzling, except that the moon was out. I could see the clouds were thin enough that I could easily see the moon, and I had no difficulty from time to time detecting the progress of that eclipse. It was wonderful. And the other thing I'd like to share with my friends here today is that was eclipse number 100 of all the eclipses I've seen. Wow. The first one was the partial eclipse in Montreal on October the 2nd, 1959. I saw that one with my mom, may she rest in peace, and with my brother, my younger brother, Jerry, who is still with us and remembered that wonderful day we had to see that eclipse. The first total was in 1963. And, I had my glasses and everything else, and it was nice until totality. And I knew that you didn't need glasses for the actual total eclipse. And so as soon as totality started, off went the glasses, and I looked at the corona. At which point, Dad just screamed at me and says, "David, put your glasses back on quickly." And I'm not going to argue with Dad during a total eclipse of the sun or any other time. Anyway, so I quickly put the glasses back on and turned away from him. And then I took the glasses back off and looked back and enjoyed the rest of the totality. Afterwards, I must have said something like, "Dad, Mom, I love you both dearly. I hope to be able to look at you clearly for many, many decades into the future. So believe me when I tell you, during the total phase of an eclipse, you don't need any glasses." And he accepted that. He agreed with that. He said, "Now that it's over, I agree with you. But I'm glad you put them back on." So my quotation is going to be at a lunar eclipse. And it's by the poet Thomas Hardy. And I was studying him at Acadia. And as soon as we started to study his novels, of course, there was no question that here is one of the great novelists of English literature, Thomas Hardy. The Tess of the D'Urbervilles was one of the books that I relish reading. I was at an AAVSO meeting years later, and somebody in the lectures, paper sessions, had a lecture about one of Thomas Hardy's novels. The novel, I'll bet some of you can guess the name, Two on a Tower. And it's about a guy who sits on top of a tower with a telescope and observes variable stars. And then this girl kind of gets to meet him, and she kind of climbs up the tower to be with him, and the story begins and goes on like that. It's a wonderful, wonderful story, and in the typical Hardy fashion. And as he's getting to the end of it, he's describing the story, and the moderator notices that his 10 minutes is up, and the moderator interrupts him and says, "I'm sorry, you cannot go on anymore because your time was up. Well, would you believe we practically mugged the moderator? The whole group said, "Oh, come on, you got to let him finish the story." At which point the moderator really said, "You're right, finish the story, take your time." And that was a wonderful thing. I immediately went, ordered the book, and read it. But as a poet, Hardy is considered a minor Victorian poet. And I'd like to argue that point right here and now. Just as I'd like to change the subject just a little bit, just a little tiny bit, before Scotty throws me off, and talk about the movie we just saw, that wonderful movie from NASA. We saw two movies. One we saw twice, and the other one we saw once. I like the NASA movies, and I would like to make my own NASA movie right now, if I may. NASA. Here is the history of the telescope. There was Stonehenge. There was Lord Ross with his telescope, the little toy that he looked through, and George Hilary Hale, who built a little kind of model you put on tabletop, the Hale telescope. But these weren't telescopes. The first telescope that Galileo looked through was the Hubble Space Telescope. No astronomy before the Hubble Space Telescope, and now the Webb telescope, and soon this other telescope. And the other telescope is going to be my favorite because it does wide field imaging. But come on, Mr. and Mrs. NASA. You're not the first person to look through a telescope. Dave Eicher, here right now, has a telescope that he looks through, and he knows and he enjoys it. And he puts it in his driveway, throws it on the street, and looks. And he lets other people look through it as well. So, Scotty, if we're going to do another NASA movie, let's at least acknowledge that the Hubble Space Telescope was not Galileo's telescope.
Okay.
And now we go back. Now let's go back to the poem. My favorite Thomas Hardy poem is this one, At a Lunar Eclipse. But he also wrote a lovely, lovely piece of verse called Lines on the Convergence of the Twain, it was called, Lines on the Loss of the Titanic. And although I'm not that greatly interested in the Titanic, there is a Facebook group that everybody is writing, and they all write, and they're so beautifully writing, and they don't say anything about anything. But anyway, it's kind of interesting to see some of the trivia about that. But I remember my grandfather was alive after the sinking. So I asked him to tell me what happened, and he said, "Oh, the whole world stopped." He said that was something that really stopped the world when that happened. And people were talking about nothing else. And some people will say they still aren't. But anyway, enough of Thomas Hardy's lovely poem, The Convergence of the Twain, in which he actually describes as much of the building of the Titanic at the same time how the iceberg was growing. And finally, till the spinner of the year said now, and consummation comes, and jars two hemispheres. And I think those two lines of Hardy's poetry are the strongest lines of anything that I've read about the Titanic. So that leads me to my poem today, At a Lunar Eclipse. And I'm doing this in honor of Sunday's lunar eclipse, Sunday's eclipse of the moon. I actually saw it. I enjoyed it. It was great. I even took a picture of it. There's not much visible, but you can see the shadow mostly on the lower half of the moon, the southern part of the moon during the middle of that eclipse, where it was closest to the penumbra, and it was really great. But here's the poem. He wrote it in 1903 after seeing a total eclipse of the moon in London. Thy shadow, earth, from pole to central sea, now steals upon the moon's meek shine, in even monochrome and curving line of imperturbable serenity. Okay, we've got the idea that he's going to write about the eclipse of the moon, but he's not. He's trying to compare the eclipse, the beautiful, lovely eclipse that some of us saw on Sunday, and the other one that some of us are hopefully going to see in 2 weeks from now, with the torn, troubled form of the Earth. And the Earth right now is going through the same troubles as it was then. How shall I link such sun-cast symmetry with the torn, troubled form I know as thine? That profile, placid as a brow divine, with continents of moil and misery. And can immense mortality but throw so small a shade, and heaven's high human scheme be hemmed within the coasts yon arc implies? Is such the stellar gauge of earthly show, nation at war with nation, brains that teem, heroes and women fairer than the skies? Thank you very much, and back to you, Scotty Roberts.
Wow. Okay, that's nice. That's nice. Well, I can hardly wait to see the new NASA video from David Levy. I think that's going to be fantastic and probably will win an Oscar. So, well, okay. So let's get started with our speakers here. We are going to bring up David Eicher from Astronomy Magazine. He is the editor-in-chief. I think he's been involved with one magazine or another about astronomy for going on for about 40 years. And so, which is remarkable because the guy's still only 35 years old. So I think that his talk this time about the tadpole galaxy is going to be pretty interesting. I was just reading about the distance of it, and it is a ARP galaxy too. So David will explain all of this in this next segment of his deep sky treasures, or his exotic deep sky objects. So thanks, David.
Thank you, Scott, and thank you, David. And are you telling me that I have to follow that? That was spectacular, David.
It was.
Yeah. I don't know how I can follow that.
It's like going on after the beetle, when there was just one beetle,
I'm looking so much forward to hearing your presentation and your talk. And whenever I listen to it, my mind goes back to the friendship that we had when you were just getting started. And I think you're going to do a great job, and I'm looking forward to enjoying this next few minutes.
Well, thank you, David. And thanks many years ago for taking pity on a dumb kid from Ohio. It's much appreciated. But so tonight I'm going to talk about yet another deep sky object. We haven't run out of them yet. So I will start sharing my screen, and I will see if I can share the right thing on my screen. Can you see, and I'll see if I can start a slideshow. Can you see Centaurus A?
Absolutely.
Okay, well, forget about that entirely because it has nothing to do with anything.
Not going to talk
Okay,
about
all right, just get that completely out of your mind, because tonight this is perhaps, if you, it's a good thing that Avi Loeb doesn't have any doubters these days, right?
Right.
Because if you believe Avi, then, eventually, one day the Milky Way and the Andromeda Galaxy may look something like this, and they will. I'm just joking about, extraterrestrial, never mind. Okay. Avi likes to have fun, I think. So anyway, tonight we're going to talk about the Tadpole Galaxy, as you said, Scott. This is UGC 10,214, which is, we're getting down into the Uppsala General Catalog of Galaxies here, a little bit obscure. This is a fairly faint object. It's a barred spiral in Draco. We're still in the extreme northern sky, working our way very slowly southward here. Very heavily disrupted by tidal interaction, which makes it an interesting object because it has a long debris tail coming off of the barred spiral disk, the bright disk, that stretches 280,000 light years long. Now, you may know that the conventionally agreed upon diameter of the Milky Way is still about 100,000 light years. So this is a long disrupted tidal tail. Visually, it's a little bit of a challenge for many observers. This is a 14th magnitude galaxy. It's a little less than 4 arc minutes across, so it's relatively small and faint, but it's interesting. And it's a great target for astro imagers, even if not quite so much for visual observers, unless you have maybe, a really nice dark sky and a 12, 16, or 20 or 25-inch scope. It's about 400 million light years away, roughly, this galaxy. And it's as I say, it's an SB peculiar barred spiral. It's also known as ARP 188 from Chip ARP's famous catalog of disrupted and active galaxies. And what astronomers believe happened here is that long ago there was a compact interacting galaxy that crossed the galaxy's plane. This was about 100 million years ago or so, and you can see it behind the disk of the galaxy now, which we'll see in a moment here. And that caused the tidal disruption that we see still going on today. Two faint supernovae, a little bit brighter than 19th magnitude, appeared in this galaxy relatively recently, and that's the only record of supernovae that we have in this galaxy. So here from Ron Stoyan's great Interstellarum atlas is the field, a relatively small chunk of Draco here. You can see the tadpole there in the middle. Couple of there's another brighter galaxy and an Abell galaxy cluster relatively nearby. And here is the galaxy. Now, this is a really incredibly remarkable amateur image of the galaxy with a plane wave 24. So this is about as sophisticated as you want to get for a hobbyist astro imager going after this thing. And of course, it looks a little better with the Hubble Space Telescope. And if you see the way this is oriented here, if you look above and just to the left of the hub of this galaxy here, away from the long tidal tail, you can see a little compact galaxy behind part of the disk of the galaxy. That's the little guy that is believed to have made a close pass and disrupted the tadpole and created this tidal tail. And of course, in a Hubble image, the whole field is full of distant galaxies as well in the background. So this is an unusual object. It's something that maybe astro imagers, I keep screaming at all of my astro imaging friends to stop shooting the same 100 objects and go out there and shoot, 10,000 different objects, so this is maybe worthy of going after from an astro imaging standpoint and with a large scope visually as well. So if you hadn't heard, we have an eclipse coming up in less than 2 weeks. And I just want to add a little bit to what Scott and David already said. And my recommendation is if you're thinking of photographing the eclipse, don't, okay? Because a hell of a lot of people are going to photograph this eclipse, and probably their images are going to be better than yours, no offense. But remember, think back to Sperling's rule, our old pal Norm Sperling from Sky and Tell. After it's over, every eclipse lasts 8 seconds. So, this is really a rare opportunity to see the atmosphere of the sun, the corona, soak it in. And, even though many of us will have 4 minutes or close to 4 minutes of totality, not a bad, timing of this eclipse, provided we have clear skies. Enjoy this visually. Don't waste time looking through a viewfinder. That's my recommendation. And remember how brief it will be. And after this eclipse in the United States, there'll be a not very good eclipse 21 years later. So it's going to be a long time coming to the next one in the United States. So I recommend really enjoying this one. And it's quite amazing, as we were talking about before we started the show tonight, back to the days of Johannes Kepler, knowing the precise timing of eclipses. First time eclipse viewers, it's quite amazing. Somebody who's never seen a total eclipse, they'll tear up. I mean, it's really emotional for people to predict down to the second when this is going to happen and see the bodies of the near solar system come together with such precision. So I recommend enjoying it, having a good time, and worrying about photography when you go to the beach the following weekend. Unless you're in Wisconsin, at which time we probably have 3 to 4 months yet until we can go to the beach. It's like winter here still. But anyway, a quick word also about something that several of us are involved with. It's coming up in May. about a little 5 weeks or so after the eclipse. Coming down the pike here, though, the Starmus Festival. And it's my privilege to be on the board of Starmus and involved with a bunch of people working on it. We are going to have incredible speakers at Starmus this year. This will be the 7th incarnation of Starmus. We'll have a lot of astronaut explorers and many Nobel Prize winners in not only astronomy, but other allied sciences. We also will have a lot of rock and roll with Brian May and Rick Wakeman and others who are on our board. So we really encourage you, it's actually easy to get. You fly to Vienna, Austria, it's not a big deal to go to Europe here, and it's a half-hour car ride from Vienna to get to Bratislava. So we hope we'll see you there, many of you. We should have about 8,000 to 10,000 people, we think, at Starmus this time. David, you're going to come and speak. Scott, we hope you'll be there. You have a lot going on these days, but we'll have a star party involving Explore Scientific, as always now. So we hope that we'll see many of you there, and we won't have to tell you what happened again after the fact, because there really is nothing quite like Starmus to get close to talk to all of these people who are really incredible movers and shakers in the sciences and in the arts. So anyway, Scott, that's all I have tonight. I'll stop sharing my screen.
Wonderful.
And thank you again for the opportunity. And that's all I have. Enjoy the eclipse, and let's hope we have a clear sky and we have many, many more eclipses to come.
Absolutely. Absolutely. Well, thank you very much, David. So I really enjoy Iker's presentations of deep sky objects and galaxies, And I will plug, he's got a great book on galaxies
Thank you.
You can find on Amazon, as well as many other David Iker publications. So
I would like to also add my thanks. I think it was, when you talked about the thrill of seeing first contact between the moon and the sun, right when it starts. I'll never forget Dad's reaction in the 1963 eclipse. And I told him it was going to start around 2 o'clock in the afternoon. And promptly, at the time I said, the eclipse started, and Dad started to cry. And I said, Are you okay? He said, I can't believe that somebody centuries ago predicted that this eclipse would start at this particular time, and he got it right. And this was a really emotional start to that eclipse.
It's quite incredible. There are always people in every group we go with to see an eclipse. There are people who are just emotionally overwhelmed, and you almost want to apologize, and they're crying, looking up, and you want to say, I'm sorry, this is traumatizing. And they say, no, this is the greatest thing I've ever seen in my life, So yeah, good crying. Yeah.
Good crying.
The best part about the eclipse is that it proves that the solar system isn't just there, it's happening. Things happen, and nothing
Absolutely.
is an eclipse.
Absolutely right. And remember, the moon is moving slightly more distantly every year. So you got to see this now. You only have about 600 million years, and we won't have eclipses anymore, total eclipses. So you got to get on board now. Okay.
That's right. And you'll be glad that you did, because everybody that's seeing a total eclipse wants to see another one. It's like going to a Starmus. Once you've gone to one, you really do want to go to as many as you can. So it is such an amazing event. And we'll have to talk sometime, David, about the formation of the ideas that created Starmus, because there's a whole story there. So
It's a great story. Sometime when we have nothing else to do. Yeah.
Nothing else to do.
A great topic idea for a future GSP.
Anytime, Scott. Anytime you like.
Okay.
They're great stories.
Okay. All right. Okay. Well, thank you, Mr. Iker. And we're going to be moving on. We are heading off to California to talk to Dr. Daniel Peluso. And Daniel is with the SETI organization. He has, I think, relatively recently got his PhD in astrophysics. He has, if you search his name, you'll find out that Daniel is also a musician. And so, actually, I want to pull David Eicher on and Daniel on at the same time, because Daniel's the kind of guy that would be perfect for going to Starmus. So David Eicher, are you still there? There we go.
Hey, everybody.
There we go.
Oh,
so I
and
promised
sorry about
Daniel
that.
I would introduce him to you, David, and because I was describing Starmus to him, and he says, well, I haven't heard of it before, and I think that anyone that is an astrophysicist and a musician, an actual recording artist, should know about Starmus.
Definitely.
Thank you, Scott.
We'll have to get you there sometime. We have, our sort of core of pals includes Brian May and Rick Wakeman and Peter Gabriel and Brian Eno. So it's a good group of, these are musicians.
That's fantastic.
Yeah. So
I don't think I'll be able to come to the one in May. That might be a little too short notice to travel that far, but it's definitely going to be on my radar for next year.
We'll probably have them every couple of years, maybe
okay.
a year sometimes, but at worst they'll be every other year, because the Garrick Israelian, the guy who organized, we want to have them as frequently as we can without killing Garrick, if you will. All the organizational craziness that goes on. Yeah.
Right.
That's awesome. Well, it's great to meet you, David.
Good to meet you, sir.
Yeah. Thank you.
Take care.
Okay. All
right. Too.
So our topic, our theme this time on the 147th Global Star Party is worlds, and of course, something that's of intense study is exoplanets. And but exoplanets, when they were first discovered, really was something only in the realm of professional astronomy, and using the latest techniques and the most advanced telescopes and all the rest of it, because to see a world going around another star is not easy to do, but it's become remarkably accessible, even with small telescopes. And so Daniel's been very deeply involved in citizen science with exoplanet work, and he is also with the Unistellar team, so I'd like to bring him on and give you the stage. Thank you very much, Daniel, for coming on to Global Star Party.
Thank you, Scott, for having me. And I love the introduction and the great poem that you read too, David. Thank you for that. All right, so I'm going to start off by making sure I can share my screen here.
Sure.
And do you see my slide titled
Yes.
Unistellar Exoplanets? Okay. All right. Yeah, so thanks for that great introduction, Scott. And for those of you that aren't as familiar with exoplanets, if you're watching out there in internet land, these are just planets that orbit around other stars. And it turns out that since we discovered our first ones in the 1990s, we now know that on average, just about every star in our galaxy has at least one exoplanet. I think that's something that's pretty inspiring. And whenever I look up at the sky and look at our stars, I think about that. That star that I'm looking at most likely has at least one exoplanet around it. Right? For example, could that one have a exoplanet around it? And what excites me and what excites, I think, many people is, could that planet have intelligent life? And I think this is, something that motivates and drives and inspires a lot of us in this field, especially when we look for exoplanets. When we talk about the search for extraterrestrial intelligence at the SETI Institute, we try to organize our quest for life elsewhere around this thing called the Drake equation, and one of those parameters is thinking about planets and because we think planets is probably a good place for life to be. And one thing I want to add too before I move on is I'm also an educator, and in my PhD work, not only did I work in citizen science with exoplanets, but also involving teachers and students in this work, which has became an important part of my project. So I'll be highlighting some of that too. And I bring this up now because the idea of life elsewhere in the universe, this also excites our students, because I could tell you one thing, talk about, bring up the topic of aliens around youngsters, and they get super excited about learning about space and how we can do this type of search. So one of the ways that we find an exoplanet is through an exoplanet transit. So what a transit is basically picking up the light from a star when a planet orbits in front of it in just the right orientation or geometry, so that it blocks out some of the light from that star. And if we collect that light over time, then we can see a dip in that brightness, which we call a transit light curve. So this turns out to be one of the most successful discovery methods that astronomers have been using to date. Just to give you an idea of what our solar system planets would look like if they all were to transit the sun to scale, you can see that in the image in the bottom left. So some of the goals that we have for exoplanet studies is to understand our solar system structure and evolution. Is our solar system typical, or is it an oddball? Like, how do we, compare to what's out there? Also, as I mentioned, where should we look for life? And with Unistellar, which I'll talk about a little bit later, we want to confirm the existence of newly discovered exoplanets and also keep track of known exoplanets. And I'll talk about how we do that in a little bit. So if you want to find out about the latest discoveries in exoplanets, a great place to go is the NASA Exoplanet Archive. And to date, we have 5,599 confirmed exoplanets. And as we can see here, that the most exoplanets are coming from this transit method. A satellite that, or spacecraft that was launched recently to help with this whole exoplanet discovery was the Transiting Exoplanet Survey Satellite. This is a spacecraft that is out there constantly surveying pretty much our entire sky and looking for new stars that or new exoplanets orbiting around stars. And it's predicted that it may find 10,000 new transiting exoplanets in its lifetime. Currently, there's over 4,400 exoplanet candidates that need ground-based confirmation. So whenever we first get this, I'll just go back a few slides again real quick. When we first get a hint of an exoplanet transit like this, say we get a single transit, we need to confirm that with additional techniques or additional transits to confirm that that was in fact an exoplanet and not something else. Science, we want to make sure that we're 100% right with what we find. So it's important that we confirm these. So that's why we say that some of these are called candidates. And that comes to be important in some of the other things I'll bring up in a little bit. So with a growing number of thousands and thousands of unconfirmed exoplanet candidates, you can imagine that it could be pretty hard for the professional astronomy community to keep up with this. Even with all of our awesome telescopes that we have in space and our professional observatories on the ground, it can be quite a lot. And another thing that becomes important with these exoplanets, once we do discover them and we confirm them, we actually have to keep things fresh. And there's some pretty great initiatives out there that you might have heard of. One of them called NASA's Exoplanet Watch. And the idea is this is after a certain period of time, that transit time, that mid-transit time, which is the time exactly when we, it's transit's going to happen, that will become still. The longer time period that goes by without an additional observation. So if we have these regular reobservations by ground-based observatories, we can keep those orbital parameters fresh. And that's really important so that when we go to look at these exoplanets again, we can find them when it says that we're supposed to see them. And also, if we want to look at these exoplanets with some of the current and future space-based telescopes, for example, the James Webb Space Telescope might want to look at an exoplanet and use its spectrometer to peer into its atmosphere to understand what it's made out of. We want to know when that planet's going to transit, so it's important to keep those times fresh. These follow-ups are also important to rule out false positives, eclipsing binaries, and they come important for single and duo transits. So a single transit is, like I said, we just got one transit so far. We've only captured one, and we want to get more to confirm it. Duo would be two transits, that we've only had two transits so far. So with this large infrastructural challenge, we have found that small telescopes with off-the-shelf parts have proven capable of transit science. A great example is the first exoplanet transit in the 90s with HD 209458b. The astronomers, in fact, one of the astronomers on that team, Tim Brown, actually built a CCD camera attached to a 10-centimeter telescope. So that's not too big of a telescope. So in fact, one of the first exoplanet transits was done with like a kind of a small, backyard telescope, which is pretty amazing. And we have all these surveys, these professional surveys that have happened, such as HATNet, WASP, KELT, LCO, Las Cumbres Observatory, Micro Observatory, Qatar. So a lot of these exoplanets, you might have heard of, like a planet that starts with WASP, WASP 58b or something like that, right? These are named after these surveys that discovered these planets. So we have been using small telescopes to do this. This is not necessarily a new thing. However, until somewhat recently, technology has been catching up, so more and more people can do this. So citizen astronomers and small telescopes can detect exoplanets, but many have had pretty advanced technical setups, and it's pretty amazing what some citizen astronomers and are able to do with these technical setups. I'm blown away by some of the stuff that they're able to do. There's a lot of programs out there too that have been around to help with this exoplanet follow-up. For example, Exoplanet Watch that I talked about. There's the AAVSO. And there's the Las Cumbres Observatory in Europe. There's something called ExoClock, which is like the Exoplanet Watch equivalent. There's the Zooniverse Citizen Science Project, Planet Hunters TESS as an example. So there's all these efforts. Okay, now the program and the project that I've been involved with through my PhD. In fact, I built a lot of my PhD thesis around this. Is this new technology with smart digital telescopes, such as with the Unistellar telescope. Now, I know, I think the Unistellar team has been on in previous global star parties, and so you might have heard of this before, those of you that have watched before, but just in case you haven't, or we have new viewers, I'll tell you quickly about what this telescope and this network is. So this is a small digital smart telescope, and it's really easy to use. It's completely app controlled. So it has all those kind of components like that you think that are on the outside of these more advanced setups, but all kind of put into like a nice little package. You can just kind of take it out of the box and use it. And it also simplifies the use, so you can actually use a smartphone app to control it. And this is amazing for outreach and education, as you can imagine. Because of the technology, we can help filter out light pollution. And because there's a digital sensor in it, we can do long exposures and do real-time stacking of images, so we can get beautiful images of the sky, such as deep space objects like galaxies and star clusters and nebulae. But besides all that, we can do science. That's the slogan: come for the enhanced vision, stay for the science. And with our network, we've grown quite a bit. I started my PhD in 2019 and just finished it about a month ago. So I'm in PhD recovery mode. So forgive me for any errors tonight. But as you can see in the map here, we've grown quite a bit. There's over 10,000 telescopes around the world, and we have many people that connect to our Slack channel to do actual citizen science. And the science campaigns that we have are asteroid occultations, exoplanets, planetary defense, comets, transients, and one I'm focusing on tonight is with exoplanets. We've also had scientific partnerships with many organizations such as NASA, the Lucy mission, AVSO tests, obviously. But we're a team, so I want to highlight the team that works on this, and some people that aren't with the team anymore aren't pictured here, but we've had other people work on this team. It's been a small team that has done some amazing science and outreach, led by Dr. Frank Marchese. And our current exoplanet lead is Dr. Lauren Skro. Then we have our comet lead, Dr. Grakowski, and Tom Esposito. Dr. Tom Esposito actually is transients now, and he worked with exoplanets with me near the beginning. We have a coder, Amory, and Dr. Ryan Lambert, planetary defense, and Ian and I have worked mainly with outreach and education, but I've also been working on some of these exoplanet projects too. And the first paper that I had come out with exoplanets with the Unistellar network, this published in the publications of the Astronomical Society of the Pacific, or PASP. And what we did in this paper is kind of show that our network can do this important follow-up that needs to be done for exoplanet science, such as I mentioned with NASA Exoplanet Watch. And we showcased in this paper that we were able to update the orbital parameters for test exoplanets. We included citizen scientists in this work, obviously, and we had 163 citizen scientist co-authors. And these came from over 21 countries, and they had over 1,000 exoplanet observations. So one of the pretty cool things about this network and how we work is when we have our citizen scientists contribute any data, if that turns into a publication, they become co-authors. And these 163 citizen scientists in this Unistellar exoplanet campaign paper, those included teachers and students. So there are these inherent education opportunities to this network, which I'll talk a little bit more in just a moment. But we also showcased here the benefits of Unistellar citizen science for exoplanet research. And some of that is just having a large network around the world that gives us broad geographic distribution, enables long duration observations beyond a single night or location. We can help mitigate localized weather. There's a portability factor, so we can travel. You can still do research in urban light polluted areas, and they're easy to operate. So it becomes a little bit more accessible to more people that have access to them. This is just one of those exoplanet transits from that PASP paper that I just spoke of. It was for TOI 3799.01. And the TOI is Test Object of Interest. We just love our acronyms in astronomy. This is a transit light curve showing the predicted transit start time on the left, and then the measured transit start time by our Unistellar network on the right. So in January 2022, we learned that the planet did not transit its star when we expected it to. And then a few months later, in March 22, we were to confirm that the planet did orbit slower than originally thought. So this allowed us to update the orbital parameters and update the test science team with this, and showcased how we can do this important follow-up work with our network. Another project that we do with Unistellar is Unite. This is the Unistellar network investigating test exoplanets. It started with NASA Citizen Science seed funding, now supported by NASA XRP. Dr. Lauren Skro leads the Unistellar exoplanets in this effort currently. This is a specific project to look for more long duration, long period transits. So a lot of the exoplanets that we found are these short period hot Jupiters. And this effort is to look for longer period. And this is to help confirm exoplanets that have only had 1 or 2 transits. And it also can help with informing future space telescopes observations to keep those transit times fresh. We've had over 15 campaigns since the beginning of this, and some notable campaigns include TOI 4465B, TIC 393818343B, and the one that I don't have to look at is TIC 139270665B, because that's the one that I worked on that I'm really excited to share with you today. This is a brand new exoplanet that our team was able to discover and confirm. And it's really exciting how this kind of all came about. So the first transit that was highlighted, this was a single transit test. So remember, this is test single transit candidates that the Unite program was trying to go after. So this was a single transit that was actually discovered in the test data by a group of citizen scientists unaffiliated with Unistellar, and they notified our team and said, hey, there's this this single transit test object. So we then worked together in a small team to follow up on it. We followed up on it with a telescope at Lick Observatory called the Automated Planet Finder, APF, which uses a spectrometer so we can collect radio velocity data to look at the star's movement in order to confirm its existence. And we also, through that data, we're able to update the possible orbital period of the planet and have our unistellar network follow up to try to catch that second transit, because we wanted to catch the second transit. So this is where we had our unistellar network observe over several months of campaigns. And this included 16 high school students and 27 non-student unistellar citizen science exoplanet observers. And the outcome was that, unfortunately, we weren't able to confirm that second transit, but we got pretty close, and we were also able to tell when the transit wasn't happening, which informs future observations of how when to not look for the planet. So we were able to narrow down the orbital period, which is a good thing. And we also learned a lot about how to perform these citizen science campaigns in the future. The confirmation of the planet mainly comes from the radio velocity for this, but this is showcasing how a citizen science network can be used to have citizen scientists and teachers and students and just the general public involved. And with this, we had a exciting opportunity with the Chabot Space and Science Center. That's where the 16 high school students came from. And we were doing outreach with them. They were excited about exoplanets. We had them use unistellar telescopes just for general observing. And I thought, well, hey, let's see if we can get them to try to catch the second transit. And they were super excited about it. So they worked with me over the course of several months and learned how to use the telescopes, learned about exoplanets, and we scheduled an entire overnight observation. We had a party for this too. So we were doing observations, and while the students were after they set the telescopes up and waiting for the next transition to realign the telescopes, they'd go and watch a movie or eat some snacks and talk about what they were learning, and then come back and do it. It was a really fun night. This is our setup at Chabot. We had 9 EV scopes set up, 8 of them controlled completely by the students, 1 of them controlled by me and students. And it's just a beautiful array of our telescopes. I think we got like the highest signal to noise from the combination of these 9 telescopes compared to other campaigns that went for this exoplanet. But this was a life-changing experience for the students. This is one high schooler's, she actually made, her name's Hannah, she actually made the bullets in the slide. And she said that what she learned was setting up and properly using the EV scope, provided observing info, readjusting EV scopes for intervals of observation. She learned introductory photometry skills, techniques used to measure the brightness of stars. That's what photometry is. And she also learned how to use this astronomical image software called JS9 to conduct image analysis. And she got added as a co-author on the paper along with our other citizen scientists. And we've heard from some other high school students that were really excited about this and thinking about going into a career in astronomy just for being involved in such a project. Now, I will just showcase quickly here the main exoplanet discovered here, TIC 139270665b. We really need to come with shorter names for these things. But this is showcasing in this graph, this is comparing the mass on the horizontal, the radius on the vertical, and Jupiter mass and Jupiter radius. And then we also have the year length orbital period in a color. And the neat thing about this planet that we confirmed is it is the densest known sub-Saturn, meaning it's smaller than Saturn, but kind of similar in size. The densest known sub-Saturn in the TESS family. So you can see it's kind of hanging out there a little bit to the right in its own kind of little new category, which is kind of an exciting thing for us. So I think here I'll ask Scott, like, you said, do you want me to go for a little bit longer, or should I stop here and ask about kind of time? I think he might be muted.
Still there, Daniel?
Oh, I can hear you. Yeah. Should I keep going, or do you want me to wrap it up?
Yes, I think that it's probably appropriate, but
Okay.
that's very exciting data, and I think it's really exciting for anybody that wants to get involved in citizen science, especially with something as cutting edge as exoplanets. I think that is just, when I started my amateur astronomy career, that was an impossibility, and something, the first exoplanet had yet to be discovered when I was getting involved. So, but anyhow, let's see.
Yeah, just to finish with what you said, Scott, my entire PhD thesis was actually called Democratizing and Enhancing Exoplanet Research with the Unistellar Network. And I think Frank has shared this. He has shared this slide before, and him and I kind of share it together. So I just think it kind of puts into perspective where we're going into the future with technology. Is now, all of us around the world, can be involved in scientific research, and I just think that's a really, really exciting thing exciting place for us to be.
Oh, absolutely, absolutely. And it's great to see people like you involved in the field. And I watched some of the videos of you before having you on the show and everything. I knew you were going to be a fantastic presenter. So,
thanks, Scott. I really appreciate you having me.
Yeah, that's great. Okay, all right. Let's, David, let's welcome space artist Michael Carroll to Global Star Party. Now, David, when was the first time that you saw any Michael Carroll artwork?
Was it during Shoemaker Levy 9 back in 1994? I believe that was then. And I think I have a beautiful Michael Carroll painting in the main part of my home. And I know Wendy and I just loved it. And I think that's when Michael Carroll and I got to know each other.
I think that's right. And those paintings are designed to hide those dirt spots on the wall. So that's great.
So, yeah, but if any of you are out there and interested in some of the best space art that you can find, look up Michael Carroll. And you can do Google Images if you want, because you're going to see a ton of paintings and illustrations and stuff. But I love the perspective that you give. They are vantage points where no telescope could go and no space explorer could go, and but they're quite accurate, and that is the skill of a great space artist.
Well, it's great to be here. It's always humbling to be in these meetings because you have so many creative, brilliant people. It's just really fun to listen to.
You're one of them, Michael, so thank you.
Oh, do go on.
So anyhow, we're going to give you the stage, but thank you for coming on to our 147th event.
Well, thanks so much for having me. And Daniel, great stuff on exoplanets. One of my favorite subjects, certainly. You are looking for things that are similar to Earth, and I'm going to talk about the Earth as it was when it wasn't similar to Earth. Let me get our screen here. Let me share our screen. Let's see. I may need to restart my keynote. Desktop one. Let's see. All right. I'm going to stop Keynote and restart it because I think we had to do that earlier. Sorry about that. Okay. Here we go. We'll see if Zoom will recognize it this time around. Open recent. Planet Earth. Okay. All right. Share my screen. Okay. Keynote. Okay. Let's see. Can you guys see my
You're not quite sharing it at this point.
okay,
So you're going down to
sorry.
share screen. You need to pick the field that you want, and then you got to commit to it.
Okay.
You got to confirm it.
Let's see. Allow Zoom to share. Okay.
These great images behind you, are these paintings and astrophotographs that you made?
These are paintings by friends of mine. I love to surround myself with paintings from talented folks.
Yeah.
All right. Well, I don't know why this won't wake up here. Me. Okay. Does that make it? Can you see that?
No, we just still see you.
Ew, that's ugly. We don't want to do that. Okay. I'm going to share screen. Okay. Oh boy. Okay, it wants me to quit Zoom, which I really don't want to do.
Is it a new computer?
It is.
Uh-huh. Okay. Yeah, there are permissions that you have to set up. Is it a Mac?
It is, yeah.
Yeah, there's a permission that you have to set up for it. If you would like, we could go to another speaker and come back to you. Okay.
Okay, sure.
Right, but you do have to go into your settings and allow Zoom to make a change.
Okay. Okay,
Okay.
I will
All right.
do
Well, that's
that.
fine. That's fine.
Okay.
So let's see. Who else do we have here? Do we have Kareem Jaffer? All right. I don't see Kareem. All right. We do have Caesar here. Caesar, would you like to go on early?
Hi, Scott. How are you?
Oh,
I am
just
ready.
fine. You're all
Okay.
set. Okay. Let's
Do
do
you
it.
do you need to see something from the South Hemisphere? I can show you something.
Yes, we always need that.
Okay. Okay. Let me
And I
show
can tell
you.
it's clear. I can see.
Yes, yes,
stars.
clear.
Tell us-
Miracle, miracle. I have ready to say goodbye to our summer last weekend to say goodbye to our summer. I took a picture, very single picture of Orion. Just maybe I was listening to David Eicher, Daniel Peluso, Dovi, and you. I was really interested in the presentations. I was making something with Orion Nebula that now is behind the building, the tower. Well, first of all, I show you a live image of. Let me show you. First of all, shovel box.
Wow.
Is in the screen. Very nice. Very nice. Let me change just a little the gain. Sorry, but this is a complex of reflecting now. You know that is not easy. Sometimes I need to make magic. And well, let me change something with the red ones. Maybe I can give you a better, maybe now, maybe changing something, the green. It's too mentioned. You can see the difference of colors. Well, here is, it's okay. Let me, now something that I make is, well, is changing the exposure. Maybe we can make more exposure and less gain to have. Yeah. 7 seconds. This is a beautiful, beautiful cluster. Maybe I can show you more near.
This looks like a really rich region of the sky.
Yes, it's a very rich. Yes, yes.
So those of you that are watching in the audience, maybe you can chat in, but I would like to know how many of you have seen the southern hemisphere Milky Way. I've seen it, and it's amazing, but I was wondering what your impression of it is like if you've been down south.
Yes, yes, it's really rich area. I can show you. I can show you moving a little the telescope. Beta or Mimosa star. To move the telescope, I'm choosing to use a faster exposure. Here we have we still having the Jewel box, and here we have Beta Centauri, not Beta Crucis, the red one star that is the reddest star in the sky. Let me try to move. Okay. Something that last week I say was that now we can let me explain. Sorry, but it's my English that I making a star trail. We can see the red one star that is this one. It's so different making a movement with the telescope. I try to show you. Okay, I need more gain. Because the stars you are watching in the same color. But when you make this, you can see maybe it's like a experiment, and maybe with more gain.
Oh wow! Look at this.
You can see the red trail of this one compared with that. The trail is totally different. It's totally red. You can see the effect.
The differences between the stars.
Yes. The path, the trail is completely red. And this is why maybe we can try with more. With more gain, that you have this effect. Sometimes this one is great for, you know, for explain the difference, because sometimes maybe the saturated quantity of light in a CCD, in a live image, you can't see the difference. And sometimes the trail help you to train again to make 6. Yeah. Something that I have tonight is that the mount is fixed with a grade, sorry. Now I need to put the gain. Where 7 seconds of exposure, okay. And we can return to the Shewell box. Now I'm moving the telescope again to the Shewell box. Sorry that the exposure are 7 seconds, but it's live. I move him. I remember that I move him with my cell phone. I move in the mount. Okay. Okay. Well, we have again in the field Shewell box. I using again more gain. Sorry, too much. Well, you can see moving the telescope how different are the stars, especially in the Shewell box. How you can see the path of these stars, red stars. You can see the difference. Well, here do you have a live image of Shewell box?
It's beautiful.
Yes, and I show you the picture of Orion that I took. change the screen. Well, this is the picture that I took 4 minutes of
Wow.
4
That is
minutes.
nice.
Yes, it is a picture without darks and flats. It's only with the telescope that you can see, not guided image, have a good polar alignment. But this is something that practically I made a less processing possible, only with a free software called Serial. Only I can show you. I can show you because I still have the stop share, and I'll show you the processing image where I have. Here,
Okay.
I'm still processing this. Here do you have the three channels, red, green, blue, and the composing of RGB. But it's the same picture that you are watching now in my screen here. And I'm happy because it's a time to say goodbye to our summer. You're saying to your spring time. The Orion is when Orion is appear in the horizon here in the south hemisphere. It's we are having happy because it's coming summer, Christmas, and sometimes you can feel stressed because it's the end of the year, you need to pay taxes, but it's Orion in our minds have a different sense for our hobby, our activity, because many times the people say, the people that make astronomy say, "Wow, it's Orion in the sky! Come on,
Come on.
time. It's the end of the year." Yes,
That's right.
yeah,
That's
yes.
right.
It's our calendar. It's very interesting for people that share the passion, Scott, of astronomy.
Yes.
And is Orion in the sky for Northern Hemisphere. Is that spring is coming for us when the Orion is going to the west earlier, or for us is when the autumn is coming, or when we start to watch Orion, Orion, sorry. We know that the summer is coming, and we need to pay all things that, because the end is the end of the year is coming.
Right. That's
Okay.
right.
Thank
It's a good
you.
thing and maybe a bad thing.
Yeah, yes, absolutely. Yeah.
Mm-hmm.
Sometimes it's great, but sometimes it's a little strange.
A little, that's right.
Yes.
Okay, Cesar, thank you so much, man. Thank you.
Thank you very much for inviting me, and it's a pleasure that you come me every week in Global Safari. Thank you very much.
Yeah, thanks, man. Thank you. Okay, all right. So let's see. We are moving a little bit differently from the schedule at this point. But David, our next speaker is Professor Kareem Jafar. He is at John Abbott College. We saw him a little bit earlier at the beginning before we started streaming. He was giving a little tour around the John Abbott campus. It looks beautiful. And he's definitely become a great friend to me. He was with me at the last Starmus festival with his whole family, which was awesome.
Amazing.
Yeah,
Amazing.
it was a lot of fun. And you and David Levy have known each other but for a very long time. Is that
I
right?
think we're over 8 years now.
Yeah.
Yeah, long time. And we've been good friends. Kareem has been visiting our Adirondack astronomy retreat. I hope he'll be there this year. And I really prize my friendship with this man. He's brilliant. He's absolutely brilliant.
I would agree. That's great. So thank you so much. I think that Kareem is the astronomy professor that everyone wishes they had. So
I don't even know how to start after that. Thank you so much. It's been too long. It keeps, I keep missing a few star parties, and then it's always a joy to come back and talk to the Global Star Party audience, see my friends. Hear from Cesar was fantastic because I don't get to see the South American skies, so I get to see them through Cesar, through Maxi, through all of our friends south of the border and south of the equator. And Daniel, I loved hearing you plugging the Unistellar for the exoplanet transits. I've been in the past doing exoplanet transits with our RASC robotic telescope that we had in California. And last year we tried to do it with the MSRO, but we were having some issues with some of the data taking. But we have an EV scope. We just haven't had clear skies in Montreal, so we haven't had a chance to play around with it yet for exoplanet transits, but it's definitely in order to do soon. So today I wanted to chat with you about the ISS MIMIC team that we have here in Canada. And this is, the ISS MIMIC is a very cool scale model. It's 1:100 model of the International Space Station that downloads telemetry data and adjusts the positions of the solar panels according to what the ISS is doing at that instant in time. It was developed by a group of NASA engineers. And what they've done since then is they've created the MIMIC Mini. And the MIMIC Mini is an educational model that can then be brought into the classrooms and used for outreach. And so outside of the US, they've now started bringing the MIMIC Mini into a few different countries. And we had the opportunity this year, just in the last couple of months, to help build the first one in Canada. So I want to share with you a little bit of that. But before we do, we always start here in the Montreal Center with a land and sky acknowledgement. So we acknowledge that we are on First Nations unceded lands, that they've taken care of the lands and the waters. We also recognize that we share the night sky with them. And whether that's the full moon, which is just passed, which was the first spring full moon, which is called the Maple Sugar Moon by the Mi'kmaq of the East Coast in the Ojibwe. It's also called the Eagle Moon by the Cree. And if you watch right now, you can see the majestic birds entering back into the lands. And we also recognize at this point the eclipse stories that a lot of our First Nations, a lot of our ancient cultures have incredible amounts of observation in their eclipse stories. And I'm mentioning this because I always talk a little bit about what we're doing at the Montreal Center of the Royal Astronomical Society of Canada. And right now, our entire focus has, of course, been on the eclipse. So it's important to recognize why the total solar eclipse is right now so important for us passing through Montreal. And for me, it's passing through my college. It's passing through John Abbott, which is just fantastic to see. So the last total solar eclipse through the eastern part of Canada, through Fredericton, New Brunswick, which gets totality this time, was all the way back in the first millennia. The last total solar eclipse that passed through Montreal was in 1932. And we're not going to get another one passing anywhere in Quebec until 2106. So that's 82 years from now. I'm pretty sure I'm not going to be around anymore. I think some of my students are also not sure if they're going to be around. So we've been working really hard to plan a big solar eclipse event here at John Abbott College campus. We have partnered with our McGill McDonald campus next door with MDA Space is going to be there with us. We're going to have a speaker from the Canadian Space Agency, and we're going to have a ton of different activities available. We're going to have, of course, our solar projection. We're going to have this amazing idea that came up from our arts and sciences program where they built a pinhole projection room. And they're hoping to build several of these for the public to be able to go in and experience the sun indirectly in a really dark, exposed area so they can really get to enjoy, spot the sunspots with how active the sun has been. Seeing it on these small projectors is one thing. Seeing it projected on a wall is another one. And then building your own pinhole projectors, building your old, putting your name with a thumbtack and having it shine through with the crescents and the partial phases, all of that is just going to be fantastic. But what really drives us is totality. And so in a week, and I'm week and a day. On Wednesday, April 3rd at 8 p.m., I'm actually running a Zoom with some of our students from the John Abbott Space Club, and we're going to be sharing what is the total solar eclipse, why is this one special for us here in Montreal, and how do we safely observe it. And anybody who's interested can join us. It's bit.ly/eclipse 2024 info to register. And yeah, we'd love to have you. We're also going to Montreal YouTube channel. But what I'm here to talk to you the most about today is ISS Mimic Mini and our Team Canada. And I have 4 of them here with Diana, who was our mentor. And I'm going to share with you a little bit about what we've done here. But this was brought on by Diana, who is one of the space outreach educators here in Montreal, who just goes above and beyond. She works in the Indigenous classroom. She works in classrooms outside of the province. She travels down to Seek every year, giving workshops, bringing in new ideas. She's also the education rep or the education facilitator at the Montreal Aviation Museum next door. So I've been doing outreach with her for several years now. And her group, Science Yourself, No G's About It, runs a bunch of different activities for kids of all ages who are interested in STEAM. Where our goal is with this ISS Mimic Mini is to have a display ready by the time the eclipse comes out, where the display will constantly shift according to this orientation of the solar panels. And then we can add in more bells and whistles as the project goes on. So on day 1, when Diana came in to talk to the students about this was on February 26th. This was right before their study break. We got a group of 5 students who were interested in participating in this. And you can see there's one little bin that she managed to carry through customs. And that was just the envy of all the customs security agents. They all came to find out what this cool thing was that she was carrying through. And everything was in tiny little packs. You had to put this together. And unlike IKEA, the instructions were not quite so straightforward. We were lucky to have Amy Medina from the Johnson Space Center helping us out and calling in remotely. The next work period was that same week. Toward the end of the week, the students said, we want to get together one more time and we want to figure out the scale of what the work is going to be. And so she brought in all of her supplies. We opened up the workshop room and you can see them at work, hard at work, these 5 individuals. But it also has to be a little bit of play as well, right? So here's Luca telling us about what he's building with the truss.
Hello, this is ISS Mimic's structural frame, built at John Abbott College in Montreal.
We could not keep a straight face for any of the videos that we did at the very start. After that, during the reading week, so during study break, if you picture, reading week, study break, whatever you want to call it in your locale, wherever you went to school, most students want nothing to do with school. These guys came in on the Thursday for the entire day, along with 2 other groups of students, also from honor science, who worked on projects that had no evaluation component to it, nothing to do with any of their actual marks courses that they are currently taking, just projects that they put themselves out for and wanted to help out with. And by the end of that day, we got the model to this point. Now, when we started working through this, we had a few different things we wanted to share, but the internet connection at work wasn't going very well. And on top of that, I couldn't get all the videos to upload properly into PowerPoint. So I want to share with you now, and Scott, stop me if you can't hear it or if it's lagging at all, but I want you to hear directly from the 5 students.
Okay. Just like feel like completely zoned out.
So hello, Global Star Party audience. I want to introduce you to the ISS Mimic Team Canada. From right to left, we have William, we have Alex, we have Quentin, we have Luca, we have Farnham, and then we have their mentor and the brains behind all of this, Diana Phillips, who is one of the teacher trainers for the Space Foundation, as well as the head of Science Yourself, No G's About It. So, gentlemen, what is this? What is it?
This is the ISS Mimic. It's a project that we were taking part of here in Canada. And basically what it is basically making a model copy of the ISS in a much smaller setting, a much more scaled down setting. Yeah, this project we've been working on for a little bit now. And we're glad to say we finally finished it. Almost. We're getting there. Just putting on the finishing touches here. And yeah, It's been really good. It's been a
So
lot
you
of
built
fun.
this from the kit from the Johnson Space Center.
Yep.
And what is Alex doing over there? What are you connecting here? Is this how it runs?
I'm connecting it to a Raspberry Pi, and right now I should set it up soon.
No worries, we'll see it in action in a few moments. So Farnham, I know you've got a ton of ISS knowledge. You want to show off some of it? You want to tell us what all these different
Sure.
modules
So,
are?
right in the back here, we have the Russian segment of the ISS. And then you can see in the front here, this is the American segment that's connected to the Russian segment. And then on the American segment, you should be able to see the Japanese lab, should be around here. And then you can see there's multiple transport vehicles attached to the ISS. You have Dragon modules and Soyuz on the Russian segment. And you have all the solar panels on it too, and they all move around according to the actual position of the real ISS.
So you're going to be getting telemetry data directly from the International Space Station to run this?
Yes, exactly.
In real-time data show exactly how it is in space in real time.
So Diana, what's the plan with this in terms of outreach? What do you plan to do with the ISS Mimic?
So first of all, I just want to say that this is Canada's first, this team. They are spectacular what they're doing. They are such bright lights, and the connective tissue between them has been extremely positive. We want to thank the creators of ISS Mimic for giving us this opportunity here in Canada. So the outreach is going to be beyond the limits. There is no limit. So the potential for this is to be able to take it not just to festivals, but also to classrooms across Quebec. And we will be taking it to the festival in Ontario, the Eclipse Festival. But we have no limits. We are really looking forward to taking it to the Montreal Aviation Museum in the fall. So what we want to do is we want to use this as a teaching tool and help children and youth understand the ISS Mimic and what it can do, and look at space a little further and get excited and get really, really, really super keen about space and space education.
Wonderful. So Diana came from the SEEK conference with this beautiful kit just under a month ago, and we've only had, I think, 4 working periods of small amounts of time, and we've already got it together to the testing phase, thanks in huge part to these 5 individuals right here. Any last words you guys want to say to the global audience?
It's just been a really cool opportunity. I'm really happy to be part of this project, part of with Diana and my crew here.
Likewise.
It's been a cool project.
So all 5 of these young men are part of the John Abbott College science programs, honor science program. I should know better than to say that. And it's been a privilege to work with them so far, and we can't wait to see what the final product shows. See you in a few moments. So here's what we had for the final product today. Tell us what's going on here. Is it set up now to show telemetry?
Yes, it is currently. It should be following exactly what it looks like in space. You just saw that move a bit. Yeah, it should be fully working.
These are live
Keyword should be.
cameras.
Yeah, I mean these we can move, whatever.
So this is next
But yeah.
being, when will it be next? Where will it be next?
Wonderful. And right now we're checking to see exactly what the telemetry should be to compare to where we are at, so that the solar panels can be adjusted. But yeah, there it goes. It's just a very short, very small movements, which will keep it from flying apart, hopefully. And Farnham, keep the Russian section from exploding. Great job.
To come off and walk around on its own. So.
So during the testing phase, that actually was happening. It was flying all over the place. If you could see the speed at which it was moving when we were testing it.
It actually has a mind of its
Plug
own.
it back in. Plug it back in.
Oh, what? Did you unplug it?
Yeah, plug it back in.
That would make sense. Like how we were working. No, because it was like going off at weird times. So is it all in? It's all in. Okay. So I think I can do this. Okay. Nice. Set it to 0. Okay.
Nice.
Okay, that works well.
But this is
100. 1,000. 100. Yeah, I mean, yeah.
That's exactly past 90 degrees. That's wonderful.
What happened to this guy?
So the debugging and the testing period has gone amazing, and we reached the point now where we have working telemetry data going directly into the Raspberry Pi, directly into the solar panels. We're able to make sure that they're oriented correctly, and now we're designing a display for them for the Eclipse event week. And then it will be a display that can be taken to high schools and elementary schools across Quebec at least, but also hopefully across the country. So that's our ISS Team Mimic Mini. And Scott, back to you.
Wow. Okay. Well, that's pretty awesome. I would love to have one of these in my office, just hanging out on my desk. I think it'd be so cool.
I'll put a word in for you. We'll talk to Amy and see if we can get you one.
Yeah, that's great. Corinne, thank you so much for doing this. Do your students often engage in, these relatively creative projects?
If I can find projects to bring in, we always have students signing up. So part of the reason why I had so much trouble getting in and getting on was because we had another group of 3 students who are taking part in an engineering challenge, and they heard that I was going to be working tonight, so they wanted to stay in the workshop as long as they could to work on their model for that design. And then we had another group earlier in the afternoon that are participating in the Beamline Challenge by CERN, and they're coming in tomorrow evening to work between the end of my lab and the start of our library night. So at some point, if I don't put a limit on, I think the students would stay there as long as I normally do. But that's what we want to see. The fact that they're this engaged, that they're this passionate, tells me that I'm doing the right things.
Absolutely, absolutely. I'm sure you have many stories too of students that have gone on to continue their studies and maybe take up a professional life in science. So that's great.
My pleasure. Thank you.
Kareem, I just wanted to add my thanks. I thought that was brilliant. It was wonderful. And if you need anybody on April the 3rd to do a little poetry and just to say a few words, I'm available because
I don't. I was about to ask you.
I don't leave for the eclipse till Friday the 5th. So the 3rd, I'm going to be here and ready to roll.
I'm sending you the link. You're going to be a panelist with myself and Evelyn, one of our exec from the Space Club.
Wonderful. I accept it. I'm looking forward to it.
Yay.
Great. Okay. All right. Again, thanks, Kareem. And,
my pleasure. See you again soon, hopefully.
Next time. Okay. All right. So we're able to get Michael Carroll back, and I totally feel for Michael on getting started with something like this, because you get a new computer and then everything's got to be configured. So, things rarely automatically just work. So, want to give it a shot again, Michael?
I will give it a shot.
Okay.
Let's see here. Get out of.
And I'll stay on with you so you're not so lonely.
That would be great. Okay. I'm going to hit share screen and we'll see what happens here.
Looks like it's working now.
Oh,
okay, that's the desktop.
Okay.
And there's your presentation.
Okay, let me get this.
I like the title. It's in presentation mode. Okay.
Okay. So are we ready? Are we good?
We are ready, and you can let it rock.
All right. What I'm going to talk about tonight, a little more briefly than we'd planned, is the many alien Earths that have come before us. Our planet is not the world that it was, and it's not the world that it will be in the future. It's gone through all kinds of strange and wondrous stages. At one point, we were a bit more like Venus, with more atmosphere, more carbon dioxide, higher temperatures. We were a bit like Mars at one point. We've gone through snowball epochs where things were cold, the air was thinner, and so we'll see some features on Mars that we find on Earth that echo those. Saturn's great moon Titan even has some similarities. This may seem strange at first, but if you look at the chemistry going on the Earth, pre-biotic chemistry, before life began, some similar things are going on in the atmosphere of Titan. And so we'll look at that a bit. But first, to Venus, one of my personal favorite planets. Same size as the Earth. There are not only parallels between Venus and Earth, but also a bit with Mercury, oddly enough, because like every other place in the solar system, we have been battered by rocks falling from the sky, asteroids, comets, meteors, dogs and cats living together. This is a painting of Mercury early on when it was volcanically active. Volcanoes in a vacuum have an umbrella shape like that. You can see the solar corona stretching up above the horizon there because the sun is just set. At the same time, right here on Earth in the Hadean era, we had a whole lot of stuff coming in. Lots and lots of craters forming, volcanism, covering the ground with molten rock, magma. And so interesting parallels there with the early Earth versus not only Mercury, but also Venus. But things did settle down for a while. In fact, we probably developed a water cycle. There was a lot of volcanism, no plate tectonics yet. And then one day, of course, there was this event. This thing is called Theia. Informally, it was about the size of Mars, possibly even a little bit larger. And one very bad day, it came up and blammed into the side of the Earth, kind of a glancing blow. Recent work indicates that it may have been following Earth for some time at one of the Lagrangian points. But gravity from Venus or Jupiter disturbed it, and it came barreling in and peeled off most of the outer layers of the Earth, made two big blobs of molten stuff orbiting each other, but fairly rapidly, within just hundreds of thousands of years, the moon coalesced from that ring of debris. And so we had the new moon and essentially a new Earth, an Earth that was given a facelift. And then the water cycle started again, and eventually we had some plate tectonics and things that we recognize today. But Venus continues to be a fascinating place with a lot of parallels of the Earth. Of course, it's a twin in size, but there's some interesting and bizarre and mysterious things going on there. At about 12.5 kilometers altitude, a whole bunch of spacecraft, including the Soviet Veneras, the Pioneer Venus probes, they all lost their little minds. As they passed through this altitude, the majority of spacecraft, not all of them, but the majority, had system-wide resets. They lost their way. The information coming back from all the probes, all the data on the experiments was crazy, and then they settled down again. Now, NASA did a study of some of the American probes and concluded that the problem was with some insulating tape that was on the spacecraft that at that temperature kind of melted. But this does not explain why the Soviet probes did the same thing at about the same altitude. Not all of them, but most of them. So one possibility that's really intriguing showed up in the Magellan radar images, and that is there are bright radar bright spots on some of the highlands of Venus. These look just like a radar signature of metal. And so it may be that on the mountains of Venus, down at their base, we have metals that actually vaporize. It's so hot. That metallic vapor moves up the mountainside, and just like right here in my backyard in the Rocky Mountains with water, as it goes up the mountain, it cools down, and it rains or snows back to the surface. So in fact, there may be iron pyrite covering the mountaintops on Venus. And wouldn't that be an amazing thing to see? Now we head out to Mars right quick to talk about some of the snowball Earth epochs. Mars is a place that is locked in the deep freeze now. It used to be much warmer. And it, in fact, has glaciers very much like this one. This is a rock glacier in Canada. But on Mars, we find what may be still active rock glaciers there, glaciers with ice locked away under the surface material. And so we see evidence of these all over the place, not only on Earth, but on Mars. Now, here is how that ties into the past on the Earth. We seem to be missing something. In fact, we're missing a billion somethings, a billion years of stratification seem to be gone from the record of the Earth's rocks. We call this the Great Unconformity. You can see it beautifully in the Grand Canyon. Here I've put a green line across so you can see where there is a nice even record up above, but then there's a gap, and then the layers of rock beneath are doing something else. What could wipe out rock like that? Well, it's possible that during two different periods on Earth, we had what they're calling the snowball Earth events. This one is a painting I did of the supercontinent Rodinia, which was during one of these epochs. And the idea is, the theory is that the planet was basically covered in ice. There may have been some open water toward the equator, but there wasn't much. And this was due to changes in obliquity and in our orbital dynamics. And so all that ice ground away, just like those rock glaciers, at the surrounding layers of geologic record and wiped it out. And so that's what may be the cause for all that mysterious missing history. At about that time, there still wasn't much oxygen in the air. But there was a lot of iron in the ocean, and that iron, because it was not oxidizing, would have turned the seas a brilliant green. It would have been pretty dramatic. Plate tectonics had not begun at this time. This was several billion years ago. But the land masses were basically remnants of volcanoes and rims of impact craters. We have a nice record of this period when life was kind of just getting started by banded iron that we find in the rocks where there was some oxidation taking place, and by things like stromatolites, very ancient life forms on the Earth. So our planet has left us with clues about its past on those. Remember that the Earth is the weirdo in this group. It's the anomaly. Venus is ruled in its atmosphere by carbon dioxide, as is Mars. The Earth is the only terrestrial planet that has mostly nitrogen and a whole lot of oxygen. That oxygen, of course, is due to life here that has transformed our atmosphere. And that life may have arisen in conditions that we find today similar to conditions on Saturn's moon Titan. The big difference, of course, is that Titan is really cold. However, it's got a lot of really cool chemistry going on. Photochemicals dropping from the sky, organic material falling into hydrocarbon seas, oceans of liquid methane, which essentially is what we heat our homes with here. So cold out there that the methane in the skies turns to rain and falls down into lakes and seas. And so, of course, we wonder about life. What about life there today? Is it possible? There are things on Titan that are actually good building blocks for living cells. And there are localized spots on Titan where it gets warm for a while. So it's possible that liquid water may be freed for long enough for at least prebiotic chemistry to take place. Some estimates say that if you have a big impact on the surface, you might have a liquid lake of water for as much as 1,000 years. That nobody knows how long it takes for life to get going. Life is one of the greatest mysteries of science still. But we have found something called vinyl cyanide. If you say this to an exobiologist, they will be thrilled. They're very excited about vinyl cyanide because it naturally occurs on Titan and it would make a great cell wall. So astrobiologists look for things like this, chemical traces that could be related to the living systems that we're familiar with here on Earth today. And of course, we'll know much more soon when we send the Dragonfly in 2027, a souped up drone to the skies of Titan. So we look back and we see that the Earth has gone through many different phases. It seems to have been an alien, very alien world at different times. And the temperature has fluctuated. We've had a global cooling, global warming. But here's the difference. If we look at trends today, global warming is much more abrupt right now than it ever has been throughout the history of this planet. And so there is some cause for alarm. Things are happening here that we need to pay attention to. But I have great hope for our planet and for us as a species. There are the greatest minds on this world working on the problems that our planet has today. We went from hell to paradise. Will we go back again to a Venus-like place? Let's hope not. I think there's room for a lot of hope. We are looking at energy. We're looking at sequestering carbon dioxide. We even are looking at new types of nuclear power that doesn't have the same kind of output of nasty stuff that conventional places do. Fusion, of course, is the holy grail. And we hope we're making progress with fusion, which has no nuclear fallout, basically, nothing nasty to haunt future generations. So I think as we look to the future, we have a great deal to be optimistic about. And looking back into history, it's exciting to see all the different stages that our world has been through and compare them to some of the exoplanets that we're finding today. I have a book out called Planet Earth Past and Present, if you're interested in digging into some of this a little bit more. All right, and thank you so much, Scott, and of course, Explore Scientific.
Thank you, Michael.
You are welcome. Sorry for all the mess earlier.
No, that's okay. That's okay. We've all endured this ourselves. So, but that's part of doing these kind of online presentations. Okay, so I can unshare your screen for you.
Thank you.
Okay, there you go. And what is your next adventure? What are you up to here in the near future?
Well, I am actually working on a book for Springer about the Artemis project and humanity's return to the moon. But the book goes beyond that. It's about human exploration of all the moons of the solar system. So I'm excited about that.
Wonderful. Okay. All right. Thanks so much, Michael.
You bet.
Okay. Let me bring Mr. Levy on. If I can bring him on. There we go.
He is here.
Right here.
No, they
There
have
we go.
something for share. No problem.
Okay, here we go. So, David, our next speaker will be Kelly Ricks. Kelly is also an artist, very creative artist, and she is an amazing sky interpreter. There are videos of her talking about astronomy. She's been on Global Star Party before, and I think that she's just absolutely fabulous. And so, Kelly, I'm going to bring you in. Are you still at the Volcano State Park?
Yes, I work in the bookstore at Capulin Volcano National Monument. So.
National Monument. Okay. All right. Yes. All right. So, and Capulin is in some super dark skies. Like, I think it's Bortle 1 out there. And
yes,
so,
definitely.
Right. And so, crazy dark. This is also pretty close to where the Okie-Tex Star Party is, and Black Mesa State Park is out there, where a lot of amateur astronomers go to really bathe in that Milky Way light. So, Kelly, thanks for coming back on again, and we're going to give you the stage. Okay,
sure.
So, yep.
Well, I'm a little flattered to be going right after Michael, a great space artist. I like to call myself an artist, but work right next to someone who's been a professional for so many years and has done so much wonderful work. It's pretty amazing for me. I have a presentation to share, so I am hoping that my screen sharing will work.
Okay.
See if I can bring that up. So I should have. Do you see my presentation?
Not yet.
Okay, let's try this. Did it come up?
No.
Shoot. Watch, Michael and I will have had the same problem.
Yeah.
It's only the artists who have visual problems,
Let's see.
It's a sign of an artist, yes. A great
Yes,
artist.
you are welcome if you have problem with sharing screen. Yes, it's our
It is our
rite of
signature
passage.
trade here.
It is our rite of passage.
I did fine last time.
Yeah, that's true.
Not sure what happened?
There's a little green button at the bottom of the Zoom application
Oh,
that
there we
says
go.
share
Zoom
screen.
application. Share screen. Share screen. Yep, I'm clicking it.
Okay. I'll tell you if it's
Yes,
catching here.
there we go.
Here we go.
Now we see that beautiful picture.
All right, let's see. File.
And you can bring
Going
that
to
in
play.
presentation mode if you want. There you go.
Yes, okay, here we go.
Wonderful.
Not too much time. Well, first I have to brag just a little bit. I just completed my very first Messier Marathon 2 weeks ago, last new moon. This is a photo I took on that night. This was from Capulin Volcano National Monument. I did have a volcano looming on my eastern horizon, so I did miss a few objects in the morning. But 100 out of 110 for a first timer, I would like to say is pretty good.
Very good.
Yes.
So, yeah. What was that?
Yeah, very good.
Thank you.
I've got 40, so you got me beat by a long shot.
Woo. Well, we all got to start somewhere. So I got my start with the parks, working in and around parks back in 2014 at Bryce Canyon, which has another extremely wonderful sky. So great that while I was there, you may not know this, I discovered a world. And just to show you some of the quality of our seeing out there, here's one of my photographs. This is taken with my camera. It is a real photograph. It's not AI. We didn't have AI back then. Here's another one. Can see interesting, I don't know, maybe signs of life there. Maybe there's some interesting water flow. Look at the bottom there. We've got, heck, what is that? Maybe some structures coming out of the surface of this world. Before y'all kick me off for being a crackpot, I will own up, this is a world. It is not a new world. It is our world. And in fact, it's what happens when Limestone erodes off of hoodoos, collects in the bottom of a stream bed, and then has its nice clay texture, and raindrops fall into that clay texture and make something that looks very much like the surface of an alien world. I remember sharing this with some of my friends while I was at Bryce Canyon. They were absolutely astounded that I could see the surface of Mars that well. But anyway, so kind of a joke, but you know, Bryce is a place that I definitely learned to see our world a little bit differently, kind of like one of these little moments of discovery with the raindrops in the clay. And I'm not alone in that. I believe that a lot of the visitors who came to Bryce, they used this word otherworldly to describe it, as though they were on another planet. And thinking about this word, some part of me thinks it shortchanges Earth just a little bit. You know, we get so used to our day-to-day, going shopping, going to school, going to work, whatever, and we forget that we're on a planet. We think of other worlds as these places of intrigue far out in the universe. Well, we are in that universe as well. And this is part of the world that I started to think about a little bit differently when I was at Bryce Canyon, such a beautiful place. And it's one reason that why in my own art, I like to incorporate aspects of our world in a context of the larger universe, how we see ourselves within that universe. And so when the topic of worlds came up for tonight's star party, I thought I'd take a little bit of a creative approach, add some art into my program. Little did I know I would be following an artist who had nothing but art in his program. But I'm also a musician. And so talking about the discovery of worlds, it's always fun to bring up William Herschel, who actually made his living as a musician. He was an organist, a violinist, an oboe player, well enough that he performed his own concertos. His sister, Caroline, who was also a wonderful astronomer and helped with his observations, was a soprano as well, also a musician. And of course, Herschel discovered Uranus. So artists are making an impact. But we're going to go back to visual art. And I have heard some people describe space art, astronomical art, as similar to art that was done by early white explorers of the American West. Now, of course, indigenous people had been there for thousands of years. They knew these landscapes well. They were sacred landscapes to them. But somebody who had recently immigrated from Europe or had lived on the East Coast of the United States for many years, going to a place like the Grand Canyon, that there was nothing to relate to. It was, for all intents and purposes, a new world, a new planet. Some of the artists that would go on expeditions, they would be so overcome by the beauty that they would encounter, the difficult things to describe, to depict, that you would have some of their paintings kind of a mishmash of all the amazing things they saw, like this one from Bierstadt, where he incorporated aspects of Yosemite with the High Sierra, lots and lots of waterfalls, just everything sort of crammed together like we see in AI today, oddly. But think about if you were going to a place like Yellowstone for the first time, how would you describe that? How could people back home believe you and not think that you were telling tall tales? An artist, Thomas Moran, went on one of the first expeditions to that region, and filled a sketchbook with drawings of these strange landscapes, eventually refined them into pictures that became part of the motivation for creating the national park system. One thing I love about a lot of these pictures as well is you always see these little tiny figures observing the pictures, observing the landscapes, giving them a sense of scale for how huge and how vast. Another analog to how we experience our view of the universe. Now, of course, we can jump right from that to our unending need to explore, what Carl Sagan termed, what did he say? I wrote this down because I knew I would forget it. An everlasting itch for things remote. Carl Sagan said he didn't know what other worlds looked like until he saw Chesley Bonestall's paintings of the solar system. This is one of Saturn as hypothetically seen from the surface of the moon, Mimas. And here we have, and I don't know if I think all of you can see the whole picture on this screen. Of course, a Cassini image of Saturn with the moons Mimas and Tethys. There's a relationship here. There's a connection here between this imagination that spurs our exploration and the exploration itself that we are enjoying back here on Earth. And as we have explored, we have always found a way to look back home. We've got a solar eclipse coming up, as we all know, and so I thought it'd be fun to show this image, mid-1800s, an artist imagining what it would be like to watch a solar eclipse from the moon. And of course, it would be the Earth covering up the sun. And I guess in this, this light extending from the side was not supposed to be the solar corona. It was actually meant to represent the zodiacal light. So dust particles in the plane of the solar system reflecting sunlight in just such a way. But without imagination like this, without the urge to explore, we may never have seen our planet with our own eyes as a planet. This was taken, the Earthrise photo from Apollo 8. Bill Anders, who took the photo, said, "We went to the moon to learn about the moon, but what we really ended up discovering was Earth." And that's often been the case. If we didn't have imagination and drive to explore Mars, we might never have gotten a picture of Earth seen from the surface of Mars, seen by the eyes of a rover, Curiosity in this case, who looked back towards us and said hello. Without imagination and the drive to explore, we may never have seen our world from beyond the orbit of Neptune, suspended in a sunbeam, the only world we have ever known. Of course, the pale blue dot. And finally, with this imagination, with this urge to explore, we are going places that we have currently no capability of even sending a spacecraft to. We can go places like TRAPPIST-1e, which I'm taking this poster from the Exoplanet Travel Bureau by NASA, which is a wonderful website to explore. And in this depiction of visitors to TRAPPIST-1, you see all of the other planets that orbit very, very close in to the little red dwarf star up here. And zooming in to this area, we see the constellation Leo looks different because from that star, the other stars would be oriented slightly differently than they are from our view. And this little yellow star, which is our sun. So always, always looking back. Oh, there it is. Yes, I forgot I had that. So not all of us.
I like this.
Yeah. So I took this photograph a couple months ago. I drove about a quarter of a mile down my street and the moon was just precisely placed. Thank you, photographers ephemeris. And, not all of us, and not all my life have I had the opportunity to live in a place that, looks otherworldly, that looks exotic and sparkly and full of intrigue. I mean, this volcanic field that I live in, the astronauts for the Apollo program came to train, to learn some geology from the area. We have a big volcanic field. They were thinking maybe they would run into some similar things on the moon. So, this is a pretty special place to be, but I think even in all of our day-to-day lives, we can take a moment to look around and recognize that of all the things that we've discovered in the universe, this is the only place that we've found life. This is the only place that we can see the wonders around us. It sounds a little cliche, but I think somewhere out in the universe, there would be somebody on another planet looking towards ours saying how amazing, how otherworldly, how inspiring, how much they need to explore. Yeah, so that's it.
Wow, that was a great presentation as well.
Thank you.
Beautiful, beautiful work.
Thank you.
Yeah.
Kelly, I really wanted to say that you have captured a part of our planet that is so rarely seen nowadays. I often like to ask people, what do you think of the world? And they start talking about the political world. But, and of course, we are having such difficulties right now and such unfortunate things happening all the time. But you have shown us a different world, a world that is seen from the national parks. I remember seeing the program on PBS years ago, America's Greatest Idea. It was a documentary about the national parks, and it was absolutely wonderful. And Kelly, thank you for sharing your take with us today.
Thank you.
Yeah, and I'd like to add that you remind me that one of my goals is to sit right alongside you and do an image, Milky Way imaging at Capulin National Park. I don't know if I'll get the shot again this year, but I've been there during the daytime, and I can only imagine what it's like at night. I imagine it is a very beautiful place, and I hope to get that shot this year. We are coming down for the Okie-Tex Star Party, so I will look
Please you
let
up. Me know and come say hello. That'd be great.
I will. And, excellent presentation, both art and pictures. David Levy already. That was an excellent summary, David. The Star Party always pulls us away from some of the things that we deal with in everyday news and reminds us to keep looking up. So with that, I'll be listening in till it's my turn. Kelly, excellent. And Scott, I need to quit taking over this global star party. So back to you.
Well, it's hard not to want to comment because I think this last, seeing the world from an artist's perspective is fantastic. So this was kind of accidental that all these, this art came to this global star party, but a happy accident, I think. And it's so wonderful to, see it through the eyes of a much different perspective, So thanks for bringing all the beauty and the imagination to this. And, making great art is hard work. And so thank you. Thanks for what you guys do. It's beautiful. Okay, our next speaker will be Robert Reeves, lunar astrophotographer extraordinaire. And Robert, thank you for coming on to our 147th event.
I'm glad to be here. I hate to wish bad things on people, but I'm kind of almost halfway relieved to find that I'm not the only person that has trouble screen sharing. It's been a running joke with my screen share ever since I've tried to be on Global Star Party. It never quite works, but we managed to get a picture up there, even though it's not quite what I want it to be. So we're going to try that once again. The theme tonight, of course, are the worlds. Of course, I present the moon, the world that is in our backyard, close enough that we can almost reach out and touch it. So let's do the great experiment and see if my screen share works. And bring that up. And my screen share is loading. Yay! Finally, it works. Okay. Well, then let's. I said let's advance. Why are you not advanced? There it goes. Taking its time today. Well, the moon, the closest world to us, and When we deal with other worlds, we're talking about planets millions of miles away. We're talking about other worlds around other solar systems light years away. But the moon is only 250,000 miles away. Not very many zeros in the distance number. A lot of people are surprised to find you can see more detail on the moon with a pair of binoculars than you can see on any planet through the best telescope you can get. So the moon offers an enormous amount of things to see, geology to explore, the artwork of the phases and the shadows and just how the moon presents itself, changing night by night. So I like to say these things about the moon. Shows us a world that is rugged yet serene, harsh yet beautiful, alien yet appealing, tortured yet calm, and strange yet friendly. We're used to the friendly face of the rising full moon smiling on us, lighting up our cold winter night or accompanying fireflies in the summertime. So the moon is something we're used to. It is our friend already. And once we put a telescope to it, we see, if my screen thing advances, oh yeah, my usual slide. I always put this in every presentation because I want people to understand, no matter what we're looking at on the moon, they were created, all the features were only created by two forces, either impacts or subsequent volcanism. So once you understand these world building processes on the moon, it makes it a lot easier to understand what you're looking at in the eyepiece. So as we sweep our telescope across the face of the moon and just enjoy what we're seeing, we see these wonderful views that we can't see on any other world. We can't magnify another planet enough, but the moon is right there in our face. So we get to see wonderful things like Tycho crater and the magnificent railroad tracks, the twin parallel rays extending off to the northwest. The almost snowflake-like quality of the ray structures around Copernicus crater and Kepler crater and Aristarchus crater. Whoops, going too fast. Amazing sights like the dark floors of basalt covered craters and the ribbons of basalt around Mare Orientale on the western limb of the moon. Or rills like Hadley Rill at the center of the image, the landing site of the Apollo 15 explorations. Backing up a little bit, the Mare Imbrium, the Sea of Rains, and the magnificent sweep of the Apennine Mountains that are the rim of the Imbrium Basin, which the Mare Imbrium lies within. Other amazing sights as the picture loads, Copernicus crater at sundown, the Carpathian Mountains above it, separating the Sea of Islands next to Copernicus from Mare Imbrium to the north. The craters, Aristoteles at the top right, Eudoxus, and Cassini on the lower left. I liken Cassini to looking like a bird's nest with two eggs in it. And sweeping along the southern part of the moon, alien landscapes like Bailey Crater, which is actually Bailey Basin now because we've reclassified it as a basin since it's in excess of 300 kilometers in diameter. And we see cigar-shaped Schiller up at the top, and between Bailey, the large oval at the bottom, just above the limb, and Schiller, a rather blank circular area, another basin on the moon that never filled up with basalt, the Schiller-Zeuxias basin. And getting up toward the middle of the moon, the Apollo 16 landing site, just north of Descartes crater. Another view of the little volcanic dimples to the southwest of Copernicus crater. You see the little field of small, tiny shield volcanoes, some with a caldera on top, right in the middle.
Wow.
And looking up at the all-time favorite on the moon, everybody loves Plato crater. It just doesn't look like a standard crater because it's filled in with basalt. Well, right at the top, the arc of the Alps Mountains, north of Mare Imbrium, got the river of basalt above it, Mare Frigoris, and then streaming further north, the heavily cratered northern highlands, the polar regions. Then go south, Tycho crater in the southern highlands with its splash of rays. One of my favorite twin craters, Pallas and Murchison, just north of Sinus Medii. We're real close to the center of the moon's visible disk. Looking closer at Plato and the Alps mountains and the gash of the Alpine Valley cutting through it. And we see the sinuous rill of Rima Plato descending the slopes of the Alps mountains and emptying out onto Mare Frigoris. Again, in the center of the moon's visible disk, the magnificent rill structures of the Triesnecker rills, the Hyginus rills, the Aridaeus rills. All of these landscapes just await your glance through a modest telescope. You don't need a powerful telescope. You don't need an expensive telescope. You can enjoy the world of the moon in your backyard anytime. Anytime it's visible, of course. And then a final look at the moon. Not all craters are round. I like to show W. Bond crater because it's distinctly square. So just banish that thought that all craters are round because they're not. But I strongly suspect that there may be no global star party next week because of all the preparations for the eclipse. So I'm going to talk a little bit about the eclipse this time because we may not have another chance before the eclipse, but the moon is a significant supporting actor in this solar eclipse business. I mean, let's face it, if the moon wasn't there, we wouldn't have any eclipses. So hopefully in 13 days, if you are lucky enough to have traveled to the center line, the skies will cooperate and you see something like this. So a little bit about the circumstances of how the moon and the sun interact to create an eclipse. Visually, as we look up in the sky, the sun and the moon appear to be about the same size, but we know the moon is much smaller than the sun. So why the size comparison? Well, the moon is 400 times smaller than the sun, but it's also the sun is 400 times farther away. So they balance out, and the amazing coincidence of that happening, I'll talk about a little bit later. Because early on in the moon's history, it was much closer to the Earth. And I'll let the cat out of the bag. This is a little bit of artwork that will appear in my next book about the moon that will be out later this year. It shows a hypothetical early moon very close to the Earth. Shortly after its creation, the Earth is still molten, still volcanic, still a place that life can't exist yet. But back then, the moon was probably no further away than the geosynchronous satellites that orbit the Earth now and give us our television broadcasts and our weather forecasts. But the moon is slowly spiraling away from the Earth. And right now, it happens to be just far enough away that when it's at perigee, it does cover the entire face of the moon. At apogee, it's a little bit smaller, 14% smaller. At perigee, it's about an average of 362,000 kilometers away. At apogee, it's about 40,000 kilometers further away. And at that distance, it's just slightly smaller than the disk of the moon. So we get an annular eclipse like we had last October. So this little graphic summarizes that. When the moon is at perigee and closest to us, it is large enough to cover the entire sun. We see the corona. But if it's at apogee, it doesn't cover the entire sun. And we get the eclipse like the practice eclipse we had last October. So last October, we got a view like this. the moon slipping in front of the sun. We still needed solar glasses to view it, of course, because anytime the visible disk of the sun is showing, that will damage your eyes if you do not have proper filtration. But the total solar eclipse, where the moon completely blocks the sun and only the corona shows, then you take those solar glasses off and you drink in what you can see with your own eyes. If you have never seen a total solar eclipse, my advice is don't weight yourself down with a heavy photography program that's going to take your attention away from just looking. On your second eclipse, maybe you can tinker with a camera. There's going to be plenty of other people taking pictures. If this is your first time, just look and remember, it will burn into your soul for the rest of your life. Trust me. So,
well put, Robert. That's great.
So, I'm talking about an early moon being very close to the Earth, and now the moon is just the right distance away that an eclipse will happen. Now, billions of years ago, the moon was too close. We couldn't have a solar eclipse. The moon would cover up the entire corona as well. A billion years from now, the moon will be too far away. All solar eclipses will be either annular or finally degrade into a simple transit where the ball of the shadow of the moon crosses the face of the sun. But right now, just when humanity is on the Earth, just when we have the imagination to look up and figure out what's happening up there in the sky, the moon is just the right distance away to create a solar eclipse. Well, what's making the moon slowly drift away? Since the Apollo missions, we've been able to put laser reflectors on the moon and measure the drift of the moon away from us within a kitten's whisker. We know the moon now recedes 3.8 centimeters per year, just a little bit less than 2 inches. So if you think about that, remember back when Neil Armstrong set foot on the moon and jump forward to today, well, the moon is about 2 yards further away than it was when Neil did his one small step for mankind. So multiply that out by millions of years and billions. Well, pretty soon the moon is too far away for eclipses to happen. But what is pushing the moon away from the Earth? It's actually our ocean tides. Just as the moon attracts the ocean tides, it creates the bulge of water toward the moon and away from it on the opposite side of the Earth. The Earth's rotation also pushes that tidal bulge offset from the Earth-Moon line between the Earth and the Moon. So it's trailing the Earth-Moon line by just a little bit. And we see in the next slide what happens is the gravity of the tides, the water bulging up toward the moon by the moon's gravity. The gravity, mutual gravity of that water on the moon is also attracting the moon. And because that tidal bulge is slightly offset, it's dragging the moon, gravitationally dragging the moon a little bit faster every time it goes around the Earth, every time the ocean tides swing around because of the moon. And given time, that's enough to push the moon out 3.8 centimeters per year. So our own ocean tides play a great deal in the fact that we are able to have a total solar eclipse in our when humanity is on this planet. And I've always thought that to be quite an astounding thing to think about, because if we had evolved earlier, we'd have this curiosity of the sun going out and the corona not being seen because the moon is too close. Or if we had evolved a little bit later and the Earth still survived and before humanity was here much later, we would never know what a total solar eclipse is. So what's going to happen in 13 days? It is extremely special. And I pray that you are going to be in the right place at the right time to see it. So there's also the question of why isn't there an eclipse every month? The moon goes around the Earth, and why doesn't it pass in front of the sun every time? Why don't we have this magnificent spectacle every month instead of sometimes a year or more? It's because the lunar orbit is inclined to Earth's orbit. The plane of the Earth's orbit inclined. We see these little rectangles. So we see how the plane of the orbit is tipped up, so that on the left and right hand sides, the plane of the Earth orbit, Moon's orbit around the Earth, the shadow misses the Earth. It passes above us or below us. Not only can we not have a solar eclipse, we also can't have a lunar eclipse because the moon will not pass through Earth's shadow. But when the nodes of the lunar orbit align with the sun, that is the point where the inclined orbit of the moon intersects the orbit of the Earth, if that is aligned with the sun, then we can have an eclipse. The moon will pass between Earth and the sun, we'll have a solar eclipse, or the moon can pass behind Earth and we'll have a lunar eclipse. So we're not going to have an eclipse every month. In fact, the way it all works out, any one particular spot on the Earth will not repeat a solar eclipse for almost 350 years. So those of us here in Texas, in San Antonio, or up in Dallas, where I'll be with the Celestron people, this region won't get another eclipse for another 350 years. But if you are not near the center line and you don't have any means of getting to see the eclipse live, I urge you to tune into the Weather Channel, because the telescope that I am setting up at the Frontiers of Flight Museum in Dallas, Texas at Love Field will be used by the Weather Channel to broadcast their live video of the solar eclipse. So if you tune into the Weather Channel, enjoy the eclipse because you're looking through my telescope. So I hope it works out for you. And in the meantime, look up there at that big bright world that's in our own backyard. Like I said, you can see more detail on it with a pair of binoculars than you can see on any of the planets in the solar system with the finest telescope available. So I always say there's much to love on the moon, and I asked you to come join me on my playground and enjoy what we see. So thank you very much, and I'll back out of screen sharing here.
Robert, that was, I think, the best of your lectures that I've ever heard. It moved me to tears.
Oh,
I think
well.
the romance of the moon and the craters is something that I share every night I'm out there. And I just wanted to thank you for sharing your wisdom, imagination, and heart with us tonight.
Well, I appreciate the commentary very, very much, especially coming from somebody as eminent in the field as you are. I enjoy talking about the moon. It is my passion, and I guess it shows through. So I do appreciate the opportunity, and I look forward to doing this again.
Yep, that's great. Okay, all right. Well, thank you so much, Robert. David, our next speaker is Marcelo Souza down in Brazil, where he's preparing for his international meeting. Marcelo, thank you for coming on to Global Star Party. I'll add you on here. And what will be your presentation tonight?
Hi, nice to be here. Thank you for the invitation, Scott. Thank you, Dr. Levy. Ever is a great pleasure to be here. I will share my screen. One moment. Let me see if I did everything right today. Okay. I think my computer today is working well.
Yes. Excellent.
Let me share here. First, I will show some images because the climate change changing everything in the world. We had last week, and this is also happening this week. The predictions for this week, you have floods here, and you have places here in our city that rain 600 millimeters. And it is a lot of water. And this is what we had here in some places here near us. And the prediction is that we are going to have rains again tomorrow. And then you need to do something about this because it was very hot a few days ago, and then began a prediction of a strong floods in all the state of Rio de Janeiro, and this happened. And we saw so many water that we didn't see years ago. You have many places underwater now, unfortunately. You see here they are living from the roof because you have the water is very high, and this is part of the regions here. And tomorrow we have predictions of strong rains again. And tomorrow we will begin also one of the biggest, it's not the biggest holiday of Brazil, but one of the most important holidays in Brazil. That is the, I don't know how to say in English, but is the Passion of Christ. That is the holiday. It begins tomorrow. And the date is associated with astronomy for this holiday because we use the Easter as a reference for all the Christian holidays in Brazil. The most important, that is the Carnival, and also Corpus Christi, that is after. And we find when will happen the Easter every year. We need to know when will be the first full moon after the equinox. Then you find the first full moon after the equinox. Then the Sunday after the full moon after the equinox is the Easter. And this will happen this Sunday. From the period April 2 to 8, we will be celebrating the International Dark Sky Week that's organized by the Dark Sky International. And this year, the period will be the same of the eclipse, the total solar eclipse in United States and Mexico. And for us, we can't see the eclipse, then we will be celebrating the dark skies. And we are now with an opportunity to see a nova. Maybe it will happen in this period. From the predictions that probably will happen until September. From now until September, it will be possible to see a nova in the constellation of Corona Borealis. This nova ET, Corona Borealis, and they are predicting now it's almost the magnitude 10, and the predictions that it will go until the magnitude 2. Then it will be very easy to see in the sky. It will be possible to see by naked eye. And this is a graphic that shows why the prediction is that this will happen. Last time that happened was in 1946. And you can see here in March 1945, they have a pre-eruption dip, and then the magnitude goes down, and then after this they have the eruption, and then there is a binary system. You have two stars rotating around, and you see from March, then they saw in March 1946. Now the same thing happened in March, April last year, 2023. Then if it is the same behavior, probably will happen again. From now, it is when happened in 1946. That's 1 year after the pre-eruption dip. Then from now, but something uncertain because we have only this data. From then we imagine that is near to happen this nova. Then many people is looking every day to Corona Borealis. Here we can see not so high, near the horizons in the north direction. And here is the position where you find the Corona Borealis. Here, near the Eta. It's not so far from the alpha of the constellation Corona Borealis. And this nova will be with the same, almost the same magnitude of the alpha. That is almost 2 in the Corona Borealis. Then you see a new star here near the Eta of the constellation. And they used here something that can make confusion. Here you see this is a fantastic graphic from the Astronomical League, and here you can see the pi from, but it's not, this pi is not from the serpent, because the constellation is the serpent head, because you have the serpent head, the serpent tail, and the Ophiuchus, that for us here is part of where you put the serpents inside. And here you have in serpent red, you have here the alpha, the P of the serpent heads, near the Corona Borealis here. And then this pi here is not from the constellation of Corona Borealis, it's from the constellation of the serpent heads. And it happened in the Corona Borealis. Here we have serpent caput, or serpent heads, and the pi is here. Oh, something happened in my computer here. Can you see it? Hey, something happened.
Oh, yeah, we can.
Oh, something happened here. Let me see what I did do wrong here. It's okay. It's the same image for you. For me, it's changing the image. Sorry, I will close this presentation here.
Okay.
I don't know what's happening.
Well, thank you, Marcello. I enjoyed this thoroughly. And I'm so glad that you were the only one so far to bring up T. Coronae Borealis. I wanted to tell you, my friend, that I've been watching it almost every night this year since it started to rise in reasonable hours. And since I'm a night owl, I've been watching it like around 1 or 2 in the morning, and it'll get to be earlier and earlier. And I keep on thinking of Starlight Nights when I think of T. Corona Borealis, Leslie Peltier's book. And if I think it's a wonderful book, it's 10 times better when he describes T. Corona Borealis. He talked about full 80 years had passed since T. Corona Borealis last shattered the symmetry of the northern crown. The beautiful alliteration in the writing that he does. And then he says, and where was I that morning? I was asleep. He said he said his alarm went off, he got up, and he sneezed a couple of times. He thought, well, maybe I'm coming down with a cold. I think I'm going to skip it tonight and go back to sleep. And then he says, and that was how I missed the night of nights in the life of T. Coronae. He said, I still watch it every night, but it is with a wary eye. There is no warmth between us. There is no warmth between us anymore. And the fact that he considered T. Corona Borealis as a personal friend really is so rare and so wonderful. And I'm so glad, Marcello, that you did as well tonight. Thank you for telling us about this wonderful, wonderful variable star.
Thank you. Thank you. And let me try here to show something. Here is Corona Borealis, near Hercules. For us, we have other corona that is easier to see. That is the Corona Australis, that is located near Sagittarius. And for us is a fantastic to see the Corona Austral during the winter, because it's very easy to see in the beginning of the night here in Brazil. I think that it's the same for you in the summer, probably. Not so high as we see here in the sky. But the Corona Austral is easy for us. The Corona Borealis, for me, is a little difficult because it's near the horizon. But we have another corona that you can see in the sky. That's Corona Austral. And I also have here the opportunity. I think that for you in the northern hemisphere will be better to see the comet 12P. And during the eclipse, it will be fantastic to take pictures of the comet 12P. I participate in a group that studies comets from the FALCS telescope project, and coordinated by Richard. Sorry, I forgot his surname. That's the work is in United Kingdom. And we took many pictures of the comet 12P. Now the telescopes that belongs to the FALCS telescope project don't allow us to take pictures because it's not so high in the sky. But it will be fantastic to have pictures of the comet 12P during the eclipse. And the exoplanets that we have almost. This is the last information that I have from Mars, that you have confirmed 5,640 exoplanets from 40,155 planetary systems. And you have, as you see, you have more exoplanets than planetary systems. Then this means that you have many planetary systems that they found more than one exoplanets orbiting. And this is the old pictures. That's the first one that I saw that I have many doubts about if it was exoplanet, because it looks like a brown star. But the confirmed one is this one. That was taken by the Very Large Telescope that you have here from the constellation of Hydra. Hydra for us in Brazil, and is a Jupiter-like planet, 5 times more massive than Jupiter. Because before I saw this image, I was making presentations talking about the process that they use to choose the candidates where it was possible to see an exoplanet due to the perturbation of the star, and also about the eclipse of the star. When you look from here, that looks that something was near that affects the star, and also when you have some kind of the light of the star that you see comes now for a period, then return, then something passing in front of the star, then was possible to see that was caused by a planet. And now everything will be easier because we have now telescopes that take pictures of the exoplanets. The James Webb took the first picture of an exoplanet, and we have many. This is something fantastic that we can see here. The exoplanets orbiting a star. This is the process now. They put something to reduce the light of the star. Then you can take pictures of the objects that are around the star. Then you can have. This is not a movie. This is a sequence of pictures taken in this around the star. And this is something fantastic. That you see objects orbiting star, exoplanets. It's not something theoretical now. You can see these objects. It's something fantastic. So the technology now is fantastic technology that you have, the new research that you have. that humanity has. And I think that we have a lot of pictures of exoplanets in the next years with these new telescopes that we're having from the James Webb, from telescopes here in Earth, when they are building the ULT, that will be a fantastic, a giant telescope here in Chile, and you see many objects that in the past we needed to imagine if this object exists by what happens with the stars. That's something that is changing quickly. Oh, now, sorry. This is our international meeting from 25 to 27 April, is almost near. And we are in honor of this Jean-Baptiste Sexton, who begins the astronomy here in our region, Brazil, in the beginnings of the 20th century. And this is the Skies Up magazine. We are receiving articles for the new edition of the magazine. Then everyone that can send, that would like to send an article, will be very welcome, because we are producing now the next magazine. Thank you very much, Scott. Thank you very much, Dr. David. Nice to meet all of you here, Robert Rivers, and all the people here. And ever is a great pleasure to be here. Thank you.
Thank you so much, Marcello. That's great. Okay. Well, Marcello does such an amazing job in South America. He's, of course, known around the world for all of his outreach work. And I think his list of ambassador titles goes on for quite a ways in education and science education and astronomy education, space exploration and the such. But he's also, just to be with him, he's so, he's just like one of those guys that just makes you feel so positive about life. And so, Marcello, thank you so much for coming on to our program.
Thank you for your kind words. It's a great pleasure to be here. Thank you very much.
Thank you. That's great. Okay. All right, David, our next speaker is Adrian Bradley. Now, you introduced Adrian to me originally because you were so taken by his Milky Way shots. And he has turned out some amazing work. Adrian, are you now available?
I can be available. I'm actually doing one of my many different things that I do, photography, and that's capturing the Ann Arbor Film Festival.
Oh, okay.
Coming to you from the catacombs of the film festival to give a brief presentation on how I plan to handle total solar eclipse. But before I do that, I need to, first of all, this is my path. So I not only do astronomy, I do regular photography. And I was capturing a Q&A session. I'm stepping away to give a quick presentation. First, on the theme of worlds, and I'm looking at the background, John Schwartz's beautiful Milky Way photography. I want to share my screen really quickly and explain what it's all about. Now, so a lot of what I like to do is photography, night photography of places that I enjoy. This is where my priest, who had passed away a week before I took this photo, this was a cabin. He would let me take photos in this cabin. And it turns out the skies are pretty dark. The motion sensor usually comes on, but you can explain to me why it went off, and it stayed off for the duration of me taking a couple of more photos. Orion happened to be situated above the chapel, above his house, depending on perspective. This was a beautiful place. And when we talk about worlds, there's a definition of astronomy that ignores the planet Earth, anything off of Earth, heavenly bodies, deep space objects, things that you can find in Orion. You're fascinated with space. I began doing this sort of night photography because I wanted to highlight the fact that we live in a beautiful world and that we have a unique position of seeing the universe from our world, whether it's the Corona commercial, Find Your Beach, and you'll see some of these pictures I've shown on Global Star Party before, but notice there's sort of a repetition, and some of that repetition can, give us comfort, whether we're looking at the moon. Here's a partially eclipsed sun, but where I plan to go is to see the fully eclipsed sun. When I saw it in 2017, I didn't take a good picture of it. So I hope to rectify that. Those of you taking pictures of the eclipse, use your settings for a full or almost full moon, and you should get a pretty good shot. Even if you handhold it, you should be able to take pictures. Try a couple different settings. My plan is to go with a couple of instruments, but if the instruments don't work, I'm just going to watch and enjoy it. I'm going to try and find a place where it's not going to be cloudy. I'm going to check the weather forecast starting a week out. And then a couple days, I'll pick a spot, whether it's Ohio, Canada, or further south, and then I'll go. And, one of the things that I like to highlight with my images and that I want to highlight when I try and get a picture of the total solar eclipse is the world around it. I think this image speaks for itself. This sums up where I'll be September/October, the Okie-Tex Star Party, where the skies are dark. This is similar. It's close to maybe 50 miles away from Capulin, where Kelly gave that great presentation, and the Milky Way is just as brilliant sitting over that volcano as it is sitting over the mesas and even the other sides of the Milky Way. We're speaking about worlds. Imagine how many worlds are in this little blip of space. Happens to be the Andromeda Galaxy. Think about how many worlds might exist in this even tinier blip that you may see in the center of the screen.
Yeah.
That's Messier 33. And of course, all of the stars along the plane of the galaxy in the Cassiopeia Perseus region. When you go somewhere dark, you see, if you happen to be somewhere dark during the total solar eclipse, you might be able to see a lot more detail. You might be able to see part of the Milky Way galaxy that's near the sun. That would be an amazing picture. I don't know if I'll get it this year, but I think I'll have to try and survive 30 more years before I can get such a photo like that. But so the whole idea behind my photos and behind capturing the spirit of the night sky, no matter where I am, is I call it a synergy of Earth along with the sky. We are a part of the universe. We ourselves are the universe trying to figure itself out. So it's quite natural to see a lighthouse next to the center of our galaxy because there is an actual connection between the two. That connection can mean different things for different people. Seeing the sun and the moon come together, and hopefully I'll be able to show those pictures if I get good ones. But if not, I'll just keep taking photos. I'll remind those of you who are Milky Way shooters that this scene happens from now. If you want to get up at 4 or 5 in the morning, feel free to do so. But you can also wait till May and June and get up a little later. June or July is when I took these photos. And you can certainly get good rising Milky Way photos in July if you have a much earlier bedtime. So, keep looking up if you want practice at getting photos of the total solar eclipse. Look no farther than any setting that you might use for the setting sun itself. Use the sun to test your eclipse glasses. If you can look directly into the sun with the eclipse glasses, you can look at it during an eclipse. And as long as it's a partial phase, keep those glasses on. As long as it's a total phase, you can take the glasses off. Ironically, it's much like once the sun dips below the horizon, you can then look in its direction safely. All of these photos were taken behind narrow apertures on a camera with the sun going down. Even if you look at the sun with without eclipse glasses, it can still be dangerous even in this phase when it's setting. So with that, I'm going to turn this quick presentation back over to you, Scott. Enjoy nature wherever you are. Try and catch a glimpse. You've heard all our presenters tell you. Try and catch a glimpse of the total solar eclipse when you can. And keep looking up. I'm going to go back up and get a few more photos of the question and answer session. And as always, Scott, thank you for having me on Global Star Party. David, thank you for sharing my images with Scott. As you know, David, I take a page from your book. I like to see the sky the way that our eyes see it and simply capture it. It's not about myself or my processing skills. It's about what we see up there. And if I can bring the spirit of the universe down in my photos, that's better than having a great image that looks good on Instagram or looks good on Facebook or other social media. I want people to be interested in seeing the sky for themselves through my photography. That's my ultimate goal.
Well, thank you, Adrian. There's something magical happening at tonight's Star Party. I think all of the presentations are at a different, higher level than they've been lately. And they're really emotional, and you're sharing your passion with all of us tonight. And I'm really just having so much fun with this. Adrian, I hope that when you go to the Okie-Tex, you may also visit David in Arizona this coming fall. If I'm here, I'd love to see you in person again.
I will do my best to get there, but I'll tell you what, David, if you are going to be at Alcon in Kansas City, I've already cleared it with the wife. I will be there.
Great.
So I look forward to seeing you all.
Yeah.
Yes.
It'll be my first time to meet you in person, Adrian.
Excellent. Looking forward to it. All right. I got to go.
Wonderful.
John.
Okay. Got to
Schwartz,
go to work.
take us home. Got to go to work.
Okay.
Take us home.
Take care.
All right.
Take care. All right. David, our last presenter is John Schwartz. It's been a while since John has been on, but John is also a artist, space artist, and he makes amazing work. Something that a lot of you may not know, but if you follow John, he comes from a family of artists, and I believe his father operated a wonderful art gallery in LA area, and John not only makes art, but he also has made constructed things for for feature movies and that kind of thing. So he has a lot of imagination, a ton of enthusiasm, and it's great to have you back on Global Star Party, John.
Thank you, Scott. It's good to be back. Thank you, everybody, for tuning in tonight on the Global Star Party, the 147th. It's really good to be back. We've been having a lot of rain lately out here, so I haven't had much time to see the sky, not as much as I'd like to, but the sky did open up recently, and it's been giving me glorious views.
That's awesome.
With my little buddy, my little viewing partner, Bosco. He's always there and helps me stay up at night. So I'm going to get this thing going. So how's everybody been? Pretty good?
It's been good. The presentations have been amazing, and you know, it's not over yet. After your presentation, we have a special NASA video presentation as well. So,
Boy, it's really hard to believe we're on number 147, right?
I know. It's gone by
So
so quickly.
I've got these in order. I haven't done too many, but the ones I have done, I'm very proud of because I've really taken my time. And, you know, the other night I went out to see the comet. It's just the clouds are always in the way for some reason. I don't know why. But when I looked up and I noticed, I could not believe what I saw in my 16 by 70 binoculars. I saw the Pleiades, the seven sisters with the moon paired. And it was spiritual for me. I've never seen that before. Absolutely amazing. I have my drawing of that. That's taken me a long time. I just barely got it done. This is the clouds parting. They finally opened up to present a glorious sky and beautiful rainbows.
Oh, wow.
A double rainbow, as a matter of fact. I've been so blessed to see these. I don't always get to, but for some reason, whenever I go outside, I see them. And just so beautiful to see nature and the earth and the atmosphere and the sunlight, everything come together to make these beautiful spectral rainbows. Just gives you hope, and you know that we're blessed to have this life. So I took my scope out, one of 25. I've just recently got 3 more. I hate to say that.
Wow, I haven't seen
2 more new solar scopes, Lunt, a 50 and a 60, because soon I'll be 70, but no. And I'm working on a 20-inch f3.3 new moon with a Ostahowski optic. So this is a 10-inch f6 light holder that I put together. The cradle I made out of woodwork, and it's just a sonotube on one of those old equatorial mounts. I don't think it was a Parkes, but perhaps a Criterion. So we set up the other night to look at the comet, and again, I got skunked. So I went to the moon. And this is actually eyepiece projection using the old 14 Meade ultra wide from Japan. Amazing eyepiece. And I projected it onto one of my receipts. That's all I had. But as you can see, it was a beautiful moon that night, and the stars in the background. Even with a moon, it's almost full. Then I thought I'd take a cell phone snapshot. So I held my new cell phone, Samsung S24, up and look at the detail that I was able to obtain with just a cell phone. It's pretty amazing.
Pretty good.
You know, and then your scope is absolutely amazing. Here's a picture of my buddy, my observing partner, when the clouds broke open. We were out and he was there with me. I created this picture because he's my best little buddy, always there. This was taken from McCoy Cross in Simi Valley, looking east as the moon came up. And we were all there outside, and I decided to try to put together a sketch. And this is what I saw. It's a beautiful moonrise. Just really makes you appreciate life when you see these. This is a nice concept that I put together. It's the moon adrift in a sea of clouds. It's almost like waves crashing on the beach. And you can see the moon just beautifully crisp floating in the clouds. It's a very, very special moment to see that. So I captured it. Of course, this is me with your absolutely amazing 6-inch triplet carbon fiber APO. I have to tell you, this is almost, it's probably the sharpest scope I got. I'd have to say one of them. You know, diffraction limited. I have many of them as I collect, but this is one of my favorite scopes for lunar and planetary. And this is what I created from yours.
Wow.
That was a cell phone snapshot. And then I put it into Procreate in the side-by-side mode. So I could literally see both on the screen. So my eyes don't have to go as far to get the detail. And I also use the grid to get proper orientation. This took an amazing amount of time to get done, but it really has a nice feel to it. Very subtle, soft, the regolith with the beautiful terminator, the craters. Another magical night. That APO is sharp, Scott. I have to thank you again. It's really one of my best scopes.
Thank you.
This was Saturn at opposition last year through my 28. This is a freehand sketch, if you can believe that. And I can tell you it took a lot of work to get it that correct. Procreate helps because if you draw circles and hold it, it gives you a perfect arc. So you don't have that jiggle from your hand. I mean, it's so hard to get a perfect line with your hand. But the tools that I have in Procreate are absolutely amazing. It's really taken my work to a whole new level. So that's opposition Saturn last year.
Beautiful.
This was my winning sketch. I've never gotten to show it other than here, but that's my 51, and it is another world. There's probably many other worlds like our galaxy has. With all the planets, you know, there's probably life. It's a very nice galaxy to look at. This is one of my latest. This is one of the hardest ones I've really done due to the low surface brightness of this galaxy. It's called the Fireworks Galaxy, NGC 6946, I believe. And this one almost killed me trying to get it right because it's so subtle and you need an ultra transparent night to really take advantage of it. And if you do a real super wide field, there's an open cluster that resides quite close. So it's one of those special objects where you can see 2 for 1 if you have a wide field eyepiece, much like your 30, that big eyepiece. It's a beautiful eyepiece. You could probably get them paired. This is just a side-by-side comparison of eyepiece sketch of the eagle. I had the pencil drawing, but I had to cut it down a little bit. So that's the black and white version. And then after inversion, and then in Procreate, I colorize it and give it the view as the filter would show you. And that would be the Lumicon 03 Gen 3 filter, as well as the DGM NPB filter, which are 2 amazing filters for the Eagle Nebula. And this is an actual view that I could see in my telescope, in my 28-inch f4.3 slipstream. This is my most proud creation to date. This was through the 16x70 Fujinons, the Pleiades, which is also known as the Seven Sisters. You know, the most pronounced stars you see are the 7. But in the Fujinons, it was just after the storm. We had those high winds, and it was so transparent. The wind shut off. Like I said, I went to see the comet, but there were clouds on the horizon, so I couldn't see it. I did see Andromeda, but when I looked up, and I panned up from Jupiter to Uranus to the Pleiades and the moon, and this was a moment. I mean, to see this for real, it's just magical to see the pairing like that. This sketch, I'm so proud of the Earthshine. As you know, what the Earthshine is our beautiful planet is illuminated by the sun and the oceans. As our planet is so much water, it reflects the beautiful blue oceans to the dark side of the moon. And that's what illuminates it. And it just gives it a surreal feeling to see this. And the Terminator was just wispy tendrils of, little crater like rims that were just, they almost looked like little hooks. It was just beautiful. I tried to capture it the best I could and get the color of the Pleiades. The Pleiades are spectacular. It's such a wonderful cluster to look at. And if you zoom in with a high power but a wide field, a big scope, you can see a lot of stars. There are a lot. So I estimate that I was at probably with two eyes, maybe at 7.1 magnitude. We had super transparent sky. It's really one of the best views I've ever had. Now I'm going to shift to planetary nebulas. When the stars blow up, they die. When they're small, not like Betelgeuse, of course, but smaller ones like our sun, they'll create what's called a planetary nebula. So this is after inversion. Again, I keep them, I can't show you all of them because they'll take too long. Now we go to color. So this is through my 28-inch. This is the Clown Nebula, and I'm not joking here. This is the Clown or the Eskimo. It's in Gemini, real close to Castor and Pollux. Wonderful object to look at. It's kind of a different shape for a planetary nebula. Depending how they blow up, if they blow out of the poles or whatever they do, it forms a different shell around it. So that inner ring is basically, we would be inside of that, incinerated. But we have a long time to go, so don't worry. This was the ring, another version. Again, this is a magical object to look at, a famous one. I could see the two stars and I could actually see hints of color. This was through my 28. This is my latest version. This, Scott, I'll tell you, this is
nice.
This
that
is a magical one.
So much. I mean, it looks so perfect to the actual visual view.
Thank you. This is through the 28 with your 9mm 120 degree. I've never seen it like this, but through that eyepiece. And
yeah.
I call it the wings. It's an angel. The star died and it went to heaven and it has wings, just like the movie Castaway when he had the box with the wings on it.
Right.
It just reminded me of that. And it's so symbolic of the death of a star. And, new life comes out of that star too. Mm-hmm. The elements, it forms other things,
That's what it takes.
So that eyepiece is amazing. I've never seen the wings like that. It just blew my mind. Anyway, thank you again for that eyepiece. I love your equipment. It's some of my best. It really is, Scott.
That's very kind. Thank you very much.
I'm just telling you, it's my surgical grade instrumentation. Now, this is the 28, my latest version of the Orion Nebula. So this is the original pencil after I brought it into Procreate and I softened it up a little, took away the little hatch marks to give it a smooth quality. Now we go to Procreate and we invert to black and white. Of course, I have to play with it a little bit.
Sure.
And now we're ready to go from monochromatic to color. So now, bam, color, just like the eyepiece view.
Just like the eyepiece view. Exactly.
I tried to emanate the blue color that you get from those brilliant stars in the trapezium. They're absolutely massive stars that have burned a hole right in the center of that, molecular cloud of gas. And they are big, powerful blue giant stars. And as you can see, it illuminates all that dust and gas. And that one cloud in front of it, it's like, contrasty because it's just dark, obscuring dust and you can't see through it. So it creates that like wing effect, like the bird of paradise flying in. I really like this one. I'm hoping to post this in the contest, Cloudy Nights. I probably shouldn't say that right now, but I'm going to do it. I've already put 2 in and I lost. So I hope this is a winner because third time's a charm. This is another version that I've created. And this one's very good view. I've also used Merco's 32-inch f3.3 slipstream telescope to get a little bit more light and a different feel, altogether. The faster scopes give you étendue, which, your eye has 26 to 25 magnitude noise in it inherently. So with the faster scope, you get a giant exit pupil and you can see a lot more detail. Things pop out that you don't normally see, much like the plasma coming out of M82. I call it coral. When we were in New Mexico, we could actually see hints of coral. It stood out, from the background as a little bit lighter gray color because of the étendue. It didn't cancel out. So it's an amazing thing. And that's what prompted me to get the new moon telescope, the f3.3. So hopefully I can experience that. We'll go to flowers because we always need to look at nature, as you said, and the beauty of nature, and just realize when you walk around, you just open your eyes and you can see so much beautiful things that you normally don't look at. But if you tune into it and key in, it really helps you connect yourself to the universe, and it's soothing and very, very calming. And, you can smell the flowers and you see birds, and it's just something I do when I walk my dog every night. I'm grateful. I look up and I see the most beautiful skies and vistas, and the air is so pure and blue. It's just really, really helps you get through it. Flowers are amazing. They reach for the sun because it gives them life, and they give us oxygen. And, it's so important that we preserve our nature and take care of this planet because it's taking care of us. Yeah. And when you look at the beauty of it, it just fulfills you deep, Nothing is ever wrong when you realize the gift. It just washes away all your pain and all your sorrow. There's nothing to feel bad about. Just having this wonderful gift. It's amazing, and I love it. Boss likes it too, my little buddy. He's there with me. He always loves the flowers. He tries to water them too, but I tell him, Boss, that's not the kind of water they like. So we got e-bikes, and I ride him to this new park, and we did 6 laps. He's been walking a lot. We go strutting like John Travolta. And I'll tell you, that poor boy he got really, really overheated because he needed his haircut. So I got him a haircut, and then it was cold because, it's been cold out here in Southern California. So I took him home, he laid on the carpet, and that was it. He went to bed and we were done. So there's my presentation.
Thank you very much, John.
Thank you.
Thank you. That's great.
It's always nice to have that observing partner,
Oh, yeah. Yep.
Yeah, I'd like to add my thanks to your presentation, John. I really did enjoy it. Before we go on to the NASA film, and I certainly hope this one doesn't also claim that Galileo was the first person to use the Hubble Space Telescope, because nobody used any ground-based telescopes. I want to show you a picture of my own, and since I cannot use, I have more trouble than any of you with sharing screen, so I could just take a picture. Wendy and I were on a cruise, and I got a beautiful, beautiful picture of Mount Vesuvius when we were docked in Naples. And then we were docked in Israel, and I got a beautiful, beautiful picture of the Western Wall. And then we got a beautiful, beautiful picture of our ship, of the stern of our ship as we were sailing. Anyway, then my camera, this camera,
Yeah.
this camera fell, and it fell all over the ship and broke.
Oh.
And, but it didn't break. I was able to kind of take things out, and what I got was a very rare multiple exposure on one frame that I'd like to share with you. And you see Mount Vesuvius at the top.
Oh, yeah.
In the middle, and the stern of our ship in the middle also, the western wall at the bottom, all in one exposure. And
how unusual.
I just thought I'd show that to you.
Very cool.
And this is what happened when you're David and you drop things.
And you drop things. That's great. Well, David, thank you. Thank you for co-hosting yet another Global Star Party. And, you know, I look forward to seeing you, you know, face to face at the Alcon event in Neath, and possibly even Starmus as well. So I'm looking forward to that. And of course, our Eclipse. So, you know, David is like a big brother to me, and really enjoy his company and our conversations that we have, you know. So, and, you know, he is the kind of guy that if you go to some event, he will spend time with you and talk, you know, of things that, especially if it has to do with astronomy. So he is very giving in that way. So it's wonderful. I want to thank all of our audience for tuning in. We had a global audience, as we always do for Global Star Party, and I want to thank all of the all the presenters. Let me bring them all on. Let's see if I can do that. Let's see. I'm going to remove my spotlight here and remove David's spotlight there, and there we are. Those of us that are left, but I can see that Dave Eicher and Kelly are watching in the background. John Schwartz is there, and of course Michael Carroll, David Levy, and myself. So, you know, we want to thank the audience, and we are going to take some time off. We've got an eclipse coming. We've got Neath coming. So we plan to broadcast live from the Eclipse in Texas, and we plan to broadcast live also from Neath. So that'll be a lot of fun. If you guys are heading towards the Northeast Astronomy Forum, make sure you come back by the booth and say hello. It'd be great to see you in person as well. And you have to go to an Alcon. If you've never been to the Astronomical League conference, this is going to be a great one. It's going to be in Kansas City, and we will be going to, I'm having a brain fade right now. What is the museum name, David?
Kansas City, it is called the Linda Hall Library.
Linda Hall Library, yeah.
And
so
it is probably the finest
really, you know,
in the world.
Yes, that's right. So many precious books and stuff from astronomers from antiquity to now. So, including David Levy's works and diaries, and his telescope is there as well. So you got to go, and we look forward to seeing you there. So stay tuned. There is still more of the Global Star Party. Our theme was worlds, and I think I found the perfect NASA video for our presentation. So let me bring this on here, and here we are. And here we go.
When considering the possibility of life beyond Earth, we look for three main ingredients. The first one is key elements such as carbon, hydrogen, oxygen, and sulfur. The second is a source of energy. And the third, and perhaps most important, is the existence of liquid water.
Water is a necessary solvent in all chemical reactions that have to do with life. Energy is required to drive these chemical reactions, and organic matter is the material from which all life that we know of is made.
Life as we know it requires liquid water. Scientists believe that life on Earth started in our oceans. Now, through our exploration of the solar system, we've realized that the moons around the giant planets have the right conditions, that there could be liquid water underneath their surfaces. And so that really sort of expands our whole concept of where you could have a habitat, where we might find life.
Water is fairly common in the universe. We've seen traces of water in large molecular clouds between stars. We've seen traces of water in protoplanetary disks. We've also seen traces of water as water vapor in the atmospheres of giant planets around other stars. And we know that water is in the atmospheres and interiors of our solar system's giant planets. So we know that water is ubiquitous throughout the universe. As far as liquid water, that's a little less common. Earth is the only planet in the solar system where we see liquid water at our surface. Moons such as Enceladus and Europa may have liquid water beneath layers of ice.
We're really expanding our understanding of what makes a place habitable. Instead of just looking for an Earth-like terrestrial planet that's a very specific distance from its star, we're learning that there can be hidden habitats that are underneath icy layers, and they can be a lot further out from the sun.
So we believe icy moons in the solar system actually harbor kilometers-thick oceans underneath their icy surfaces. These icy moons and their subsurface oceans may be some of the best places to search for life elsewhere in our solar system.
Enceladus is one of Saturn's many moons, and it's a very small moon that people tend to kind of ignore because it's so small, about 500 kilometers in diameter. But decades ago, in the 1980s, from ground-based observing, we found out that the location of Enceladus relative to Saturn happened to coincide nicely with Saturn's E-ring. And so we were thinking that Enceladus had something to do with the E-ring particulates, the icy material, but we weren't sure. What we later find from Cassini was that we directly determined that there are indeed plumes jetting out of the south polar region from cracks in the south pole of Enceladus in the crust. And it's dominantly water-rich material, just jetting out into space. And so the way we saw it, Cassini happened to be located where Enceladus was backlit from the sun. And so you saw this curtain of beautiful diffuse material jetting out of the south polar region. Quite breathtaking, actually. Even more, we were able to use the different complements of instruments on board Cassini to go after the chemical composition of the plumes. And that's where things got really interesting. So number one, that's because of liquid water. There's definitely a liquid water reservoir. It's subsurface below the icy crust, but that is there. Number two, the chemical composition of the plumes told us that there's a lot of organics, things that make up amino acid and things on life that are very interesting. And number three, what we were really looking for is a source of energy. On Enceladus, photons from the sun aren't going to work because you can't penetrate the tens of kilometers of icy crust to get down to where the liquid water reservoir is. But what Enceladus does have is hydrothermal vents. It's very hot into liquid water. That has a lot of analogies with the ocean floor, where we have a form of releasing chemical energy via something called serpentinization. And so we think that Enceladus might have that potential to have an energy source being chemical, not sunlight. And so you put all that together, and Enceladus has all the ingredients, or most of what we need, for life. That makes it a very astrobiologically interesting object to study.
Europa is one of the largest moons of Jupiter, and we believe that Europa has a subsurface ocean tens to hundreds of kilometers thick. And so this ocean may be one of the best places to search for life in the solar system.
There's been 3 space missions that have provided evidence for Europa harboring liquid water. The first one is Voyager in the late 70s. The second one is the Galileo mission in the late 90s. And most recently, Hubble, which detected plume-like emission from hydrogen and oxygen, which is closely related to the existence of water beneath its surface.
These plumes may be directly ejected through cracks in the surface of the moon, and therefore what we're seeing in water vapor plumes is the actual ocean water from the subsurface of the moon.
As these plume particles are ejected to space, solar radiation is going to excite these water particles, creating vibrational modes. Now, these vibrational modes are signatures that can be detected at infrared wavelengths by the Keck Observatory. So we observed Europa on 17 days. What we found is that the majority of observations have no presence of water. However, on one of those days, we detected water. We detected H2O. In the past, Hubble provided indirect measurements of water by detecting hydrogen and oxygen. But now we have directly detected water for the first time.
Both the Webb telescope and the Europa Clipper mission will give us a much more detailed picture of the surface of Europa, its cracks and crevices, detailed pictures of the water vapor, as well as other molecules that may also be emanating from the subsurface of Europa. So both of these missions will give us a great picture of whether Europa is truly habitable.
Titan is a moon of Saturn. It's the second largest moon in the solar system, and it is about 2 times larger than Earth's moon and actually bigger than the planet Mercury. And Titan is also interesting. It's the only moon in our solar system with an atmosphere. It's surrounded by sort of an envelope of gaseous nitrogen, just like our own Earth is. Titan was first discovered by telescope observation back in the mid-1600s. The first spacecraft observations were made of Titan during flybys through the outer solar system. That was in the late 70s and in the 80s. But we really were able to explore Titan in depth with the Cassini-Huygens mission. The Huygens probe was dropped into the atmosphere of Titan, and it made measurements of chemistry, and it took images as it fell to the surface. And that was back in 2005. And since then, the Cassini orbiter made over 100 close flybys of Titan.
Cassini, in its design with the different instruments, we purposely were picking instruments that could go into longer wavelengths into the infrared so we could really understand the moon. We were able to basically peel back the layers of Titan to really see what was below, and it was remarkable, very Earth-like.
The landscape is similar to Earth's in many, many ways, but with a little bit of a twist. So on Titan, you can find dunes, you find lakes, there are river channels. The atmosphere is very dense, and you can get clouds and smog, and you even get rain.
We saw winds, we saw seasons, and one really important thing we saw was liquids pooling in the polar regions on the surface, a lot of it.
But because Titan is so cold, those features are all made of very exotic materials compared to what we would find on Earth. So the lakes and the rain are made of liquid methane. The crust that forms the surface of Titan is actually water ice, but it's so cold that it's as hard as rock. And in the atmosphere, we get this organic chemistry that forms large organic molecules and particulates. They fall down to the surface and then behave like dust or like sand does.
So it makes us want to go back to really understand the complex organic environment of that surface and what it means for either past life or maybe future life.
Dragonfly is a mission that was just selected by NASA to fly to Titan and arrive in the mid-2030s. Dragonfly is going to make a whole bunch of measurements to help us understand the environment on Titan and its potential for habitability. We'll be taking measurements of the atmosphere. That includes things like pressure, temperature, winds. We'll probe the surface to try to understand what materials the surface is made out of. We'll also be drilling into the surface to look for the types of organic molecules that are present and to try to see if we can find any examples of compounds that mimic the types of building blocks we know we need for life on Earth. We don't really know how life started on Earth. We don't exactly know what the chemical environment of Earth was like before life started. So with Titan, we have this really unique opportunity. There are times in Titan's past where there could be liquid water on the surface. Impact craters can generate impact melt, and there's a potential for possible cryovolcanism to erupt some liquid water onto the surface. And so we know that there's a rich organic chemistry going on in the atmosphere. We know that's depositing to the surface. If there were times where those organics and the liquid water environments were mixing, then there may be some really interesting chemistry taking place. When you have these processes operating for hundreds of millions of years, how far can they get you down that path of chemical complexity? And can we see reactions and molecules that start to look something like what we think of as essential elements for our biochemistry for life on Earth?
In the future, looking forward as opposed to looking back and thinking about Titan as a chemical laboratory for the prebiotic Earth, I like to look forward thinking about what's going to happen when the sun evolves and warms up and the habitable zone actually moves out to where Titan is. And it will. You have all the organics, you're going to have a source of energy, all we have to do is melt the frozen water and we're going to have a pool of organics just embedded in liquid. Titan might actually have a chance at that point to harbor life.
So when we think about ocean worlds, it's good to compare them to what we know about Earth. In total proportion, Earth is about 0.1% water. An ocean world is a body that has, in proportion, about 10 times more water than Earth does. And when we think of the TRAPPIST planets, those planets have about 50 times more water in proportion to what Earth does. Ocean worlds do appear to be common in our galaxy. As far back as the early 2000s, we had astronomers, some of them still here at NASA Goddard, that suggested that we would have ocean worlds orbiting low-mass stars. Recently, we've looked at about 52 exoplanets, and these are low-mass exoplanets. And what we found is, of these 52 planets, 1 out of every 4 may be an ocean planet. And when it comes to these ocean planets, over half of them may be ice-covered ocean worlds. And so Enceladus and Europa may serve as small-scale analogs of these planets.
So there are a number of different ways to search for life on planets around other stars, but the key method is the study of the atmospheres. We can search for signs of life, biosignatures we call them, things like oxygen, water vapor, carbon dioxide, even more unusual biosignatures, things like chlorofluorocarbons or other things that are only produced by intelligent life. By looking for these key constituents of planetary atmospheres that signal life, we can discover life forms on other planets that we could never actually visit in our lifetime. So this is very analogous to how we study the atmospheres of moons and planets in our own solar system, and really makes the connection between studying the plumes of Europa and the atmospheres of planets around other stars.
What I would like to see is the definition of a habitable zone expanded. We don't want to keep thinking too narrowed about liquid on the surface, but broaden the scope and really try to embrace other worlds that might seem too far from the host star and frozen out when they really aren't frozen at all. At great depths, they harbor a warm, hydrothermal-driven, liquid water environment.
Did you know that you can participate in solar eclipse science with NASA? NASA's citizen science projects are collaborations between scientists and members of the public, no matter your citizenship.
The general public is best suited for these kinds of projects because they will be on the ground over the whole path, and that really can be kind of a force multiplier for how many observations you can take.
Several volunteer science projects are gearing up for the 2024 total solar eclipse that you can join.
There are many mysteries that come about during a total solar eclipse, ranging from the part of the sun that we can very rarely see, the corona and the birth of the solar wind really close to the surface of the sun, as well as the effects on Earth.
Using telescopes and cameras that are safe for viewing the sun, volunteer scientists across North America will capture images of the total solar eclipse. Scientists will study these images in detail, tracking how plumes of solar material move through the sun's atmosphere. But be careful, without proper tools and techniques, you can damage your eyes and your camera. Amateur or ham radio operators will send radio messages to one another during the eclipse to see how changes in the upper atmosphere distort radio signals.
The opportunity to conduct research and participate in citizen science during the upcoming total solar eclipse is really special. The sun is always changing, so we don't know what it's going to be doing right at that time.
As the moon blocks one portion of the sun, it can make other portions easier to see. Working with local scientists at an observatory in Southern California, participants will observe magnetic hotspots on the sun as the moon passes over them, revealing details they normally can't detect.
We have a public who's interested in different aspects of heliophysics and can actually contribute to our science. And so we really invite people to participate, and we need all hands on deck for that.
Follow Do NASA Science on X and Facebook to see how you can get involved in NASA citizen science.